today we are going to be looking at the last piece to have a functional VTubing, open source VTubing stack, Live2D replacement, which is physics. So I don't know if you guys saw, but there is okay. I can say this now. There are other people I've been working with on stuff. So besides me working on the Live2D SDK replacement, I am also working with / collaborating with Asiana, who is working on a Live2D editor replacement for rigging, and with Aerodozer, who is working on a VTube Studio replacement. So actually, the VTube Studio replacement is OpenVT, which already exists using the Live2D SDK. So that is getting upgraded, shall we say, to use Ayagami. So yeah, this is all going a lot faster than it might seem. But we are missing one big piece. We are missing physics. There's no physics reimplementation yet. So check out my socials if you want to see some of the stuff I just mentioned, because I have boosted a couple things. Yeah, so this is really kind of the last big thing. After physics, that's yeah, there's a few loose ends to tie, but nothing really particularly major. So let's see what we can do today. Let me say hi to everyone. Hello, Flamingo, hello, Wolfo, hello, Sphere, hello, Xasclery, hello, MGK, hello, Tondo, hello, Martens, hello, Cusco, hello, Godslayer, hello, Miller, hello, Fabi, Tix, hello, Bond the 5th, hello. Did I say Wolfo? I did. Hello, I think that's it. In there, anyone else? I think that's everyone. MGK, I think. Yes, I thought that was second. Hello, Eugene. And hello, Rainbow, Soxo, Jeff. Have you looked into the Avian crate for 2D physics? No, we might be able to use an existing physics crate, but honestly though, the thing is the physics in Live2D are extremely simple. It's just pendulums. So this is less about, you know, making physics work in general, because like there are a million ways you could do physics. This is more about figuring out exactly what behavior VTube Studio has, which is using the Live2D SDK, and replicating that. So we need to understand like what the numbers mean in the physics configuration file, and numerically come up with an algorithm that at least, you know, if not exactly, at least is pretty close to matching what the Live2D SDK is doing. So it could be the case that you know, that happens to be matched by an existing physics library, but honestly, the actual math is going to be so simple that I think it's worth just re-implementing it, and so then we have a reference implementation that other people can use and doesn't depend on like a large library. But I think it's going to be pretty easy because I've done this before. I've done a from scratch non-reverse engineered implementation of a very similar physics engine, and honestly, there are only a couple ways it could work. So I don't think it's going to be a big thing. I do not work at Google. All right. Hello. Did I say that? I think that's everyone. Yeah. Hello, Jojoda. Okay. So without further ado, also I've been working on a specification for Mach 3. So I have about half of it written, about a bunch of prose, and once the physics is done and maybe a couple things fixed, I think it will be ready to release. So, for the reasons, sorry. Okay, it doesn't have to be a perfect like one-to-one match. First of all, we are not looking to have like identical output down to the rounding error. Like that is not a goal. And in fact, if we had that, that would be kind of a sign that some of the code was stolen, because it's almost impossible to match the rounding error exactly with anything. That's not the goal. The goal is to have, you know, within visual equivalence. So, you know, to like within two significant figures, I'll be happy. And the way the physics works in Live2D is that it is pendulums, which are essentially like, I don't think they actually simulate entire pendulum chains, because that is actually, depending on the lengths, I think that is a chaotic system. I'm pretty sure they do the same thing I did in the previous implementation of this, which is that you simulate a pendulum, and then the other pendulum chained on it doesn't have any influence on the first pendulum. So it's not a realistic simulation, and it doesn't have to be. So that kind of system is, how do you say, like is what's the technical term? Like it's a stable system. It's a converging system. So even if there is some error, the error will not accumulate. It will not result in results that over time are wildly divergent, because it's not like when you are simulating physics in, say, a game where objects move to a different place, or where, like error will accumulate. A pendulum always goes back to zero if you're not moving. So there is no place for error to accumulate. So it should be fine. Let's see. So, and also I want to improve it because there are some things about the physics, like for example, the way it works in VTube Studio with this model that I'm using right now. The drag physics thing, I don't know if you know that you can drag models around in VTube Studio, right? And it's turned off right now. I'm actually going to show you how bad it is. So if I turn on the physics on VTube Studio, I mean, it has physics right now, but it doesn't have the drag physics, right? If I turn on the, if I actually turn up the drag physics, see how my face is going around in a weird angle? Like this is not how it's supposed to work. Like this is very strange. And that's because, and also another thing with the VTube Studio is that vertical does nothing. It only has horizontal drag physics. And that's because you need to adjust the physics settings for different physics groups. And this model doesn't have that. And it only supports, I think, horizontal influence on the pendulums. And that doesn't make sense because the pendulums, even though they are, in a model horizontal, they are used to model vertical things that aren't pendulums in models. They're an abstraction. They're not really, just pendulums in the physical world. So you would want to have, for example, the y direction to influence certain pendulums and not others. Sophisticated cascades of delay functions. No, it is pendulums. The Live2D Physics is 100% pendulum physics. That is literally how it is modeled in their editor. So we have weight and gravity and things like that. But there's some interesting there's damping involved and stuff like that. So basically we're going to try to see if we can feed in, if we can feed the some test data into VTube Studio and make sense of roughly what it's doing. But yeah, I would like to do better than this eventually. So we need something that's compatible, and then we can expand on it. Longitudinal and stringy physics coming in a Mach 3 Android. Actually, yeah, another thing is that the time I did this in the past for different software, the pendulums were actually attached to the model. So it was way more realistic for things like earrings or anything that's actually swinging. And I would like to have that as an extension in the future. And I'm pretty sure we can work with Alziana to add that to her editor, which is called Umamo. So, but first it's getting the existing algorithm to work, and then we can improve on it. Yeah, I saw the bugs. The color stuff. Okay, so there's two things about the color stuff. One is that the demo, not the renderer. The renderer supports linear blending, but the demo that you see on the web and that you can build only has sRGB blending because eGUI currently only supports sRGB blending. I filed a bug about that because I feel like they did that for the wrong reasons. I need to actually send a PR and a patch to fix that so we can use linear blending, because I'm pretty sure VTube Studio is using linear blending. The other issue is that I am not sure if the color space for multiply and screen colors is sRGB or linear. In my code right now, because we're using sRGB everything, it's being treated as sRGB. It is quite possibly linear. But those things need to be confirmed. So that's most likely why the blending is off. And the first thing that has to happen to fix that is the eGUI mess, which is kind of, auxiliary. The renderer that I have will do linear blending, but, if you give it a linear frame buffer, which eGUI does not. So, yeah. Okay. Yeah, I think it's both. So don't worry too much about that. If we have time at the end of today, I might take a look at it. But those are going to be very, very minor things that should be very easy to fix. So don't worry too much about it. And the other thing is that I do know that VTube Studio does some things wrong with the blending, and we're not trying to replicate the mistakes. So some things are okay to be a little bit different. But yes, I am aware that the color blending is not exactly the same. So I will look at that. Okay. Let's go. Let's take a look at the physics though. So I'm actually gonna do this in Python first because I don't think there's much reason to to work on the physics in like Rust or anything like that when we are going to be playing around with the V2 Studio API and it's going to be experimenting with math formulas. The iteration is going to be a lot easier in just a Python script. And then once we have a algorithm that works, it's going to take 10 minutes to port to Rust. So yeah, we're going to do it like that. So let me just check here that we are all good. I think we are, though. Let me just reset my model here. Oh, I have to do one thing, though. 1 second. Okay, I think we're good. So, here we are, and let's first grab the tool that I already had. So we have this in dev mock3re, mock3re. And just open this directory here. Oh, that is a hack I did for my chair. I modified my model so I would have a part I could turn off for the chair because I was doing something. Okay. So, here we have the stream params, and I'm gonna change that to to some kind of tool to test the physics. So let's see how we can do this. So one thing about the physics is that we don't actually need a model to test it. We can just have physics, like we have dummy parameters in the model and just have physics driving them. And it shouldn't actually need much of a display, but because we might want to have a display just to, make it easy, make it more visual, I think we're gonna have something there. So I think we can probably just have a couple output parameters and display them on the screen to, do a simple thing, something like that. So let's first do we can use the rotation test, probably. Actually, no, we need to do them with parameters. So test param, let's call it let's call it physics test.py. So I think I can just use my viz grid thing that I always use that goes from 0 to 1, and I already have a cursor here, so I can probably just put it somewhere. So for the cursor, we're not going to bother with blends because those are annoying. Let's just have a rotation deformer. And the rotation deformer has an angle, a scale, and a translation. And so we want to have some forms for that. This does create a form. I think we can just add more to that. So the first form becomes the translation there, and we can just add another one. And so the translation for the rotation form, we don't need those. Let's just say it goes to 1 horizontally. So we're going to just move this horizontally, displaying the parameter. And rot.count rot forms equals 2. And then we need to set the parameter on this. So let's get rid of these things. And so we have a parameter that goes from 0 to 1 just to make it easy. Actually, let's do it from -1 to 1 because if we're doing pendulums, that's going to be a little bit more logical. So let's do this physics. Let's call this output 1. And we need a key point array. Let me open the test parts here and copy some stuff. So I have a key point array and no blend shape stuff. And let's go this param1. And we're not going to do any limit things and no draw items. So we need to set the forms for the rotator. Oh, we have a single keep on array set, which is empty, right? So we need another one for this one. And so the key point array set needs these things. Actually, let's put this into a function. So we need a key point array with 2 key points, and a key point array ref with that key point array, and then a key point array set with a single key point array. And so the param needs to have I key point and count key points from the key point array. Okay, that makes sense. Then we can just grab it from param. No, this is the key points though. We need the, sorry, we need the, I forgot. Class, param. Yeah, I key point array is what we need. Yeah, so we need that one. Hello everyone. Is this a Giga Physics? It's for everything physics. I mean, my hair is physics. What's your professional tech background? I mean, I've done a lot of systems engineering and kind of low level stuff, I guess. Okay. Let's see. So let's do a param1 equals output param. We create that. And then for the rotation, we can just take the rot dot and that needs a I key point array sets. So as the key KAS, and we don't have that actually, we need that, so let's return both of those. So this should give us a rotation that moves from 0 to 1. And translation needs to be 1x, 0, y. And I'm going to do another one. So we have 2 of them. param2, KAS2, rot2. And we need a second cursor for that. Did I lose the cursor? No, it's here. Let's move these down. So we have a cursor 2. Why is my throat always bad? I thought always bad in the mornings. I don't know why. So the translation of this one will be 1, and then we also need the original form translation, which is done here, I think. Rod takes arguments. Yeah, translation. So we move this one down, and that will give us a translation. Let's just call this make param. Because then you can just have dummy input ones. And it is thinking. Okay. I think that should be enough for that. Let's see if that works. Okay, we need the name here. Actually, it's called ID, but whatever. Mesh object is not callable. All right, yes. It is not liking index. Is the index out of range? I did something silly here. Oh, because limits is not... Okay, yeah. Max min default. Yeah, so max... Yeah, I always get this backwards. Max min default is 0. Okay. There we go. Okay. Does this load? That is very stuck. I remember that happened when I had a duplicate art mesh name, which is exactly what I have. So no wonder it is confused. Because we have 2 cursors. And it might be very broken now. Okay, now that one works. Oh, a validation failed actually. What happened here? Assertion error. The former keep on erase that's 1. Oh, there's first of all there's 2 rotation deformers with the same name, which is not great. Let's change that just in case. But there's something else wrong. Possibly the key point erase sets? This is supposed to be cast 2, but that shouldn't be the problem. Is the form count wrong or something? No. Oh, because they're changing. Yeah, this has to be the typed one. So it's like rot to. This only returns the rotation deformer, not the. No, it does return the rot deformer. Okay, it needs the typed also. Typed dot. Because for some reason this parameter is duplicated there. Oh, because the translation, right, yeah. Because this is like a name tuple. How do I, yeah, this is annoying. But it's failing it. Comes out from equals total keys. Oh, this is tight. Oh, and then it doesn't like the multiply color. I thought I had that. It should default to 0. Oh, right, because the second form wants to have a multiply color that is linear with that. Okay, yeah, it just needs another color because of the way Mach 3 works. Okay, so let's just add we need to set the form here to form dot. Because it does things. Okay, now it's happy. Okay, so now we have a, yeah, so we have that. It's in the middle, which is because it's 0, so hopefully this will actually work. If I go to expression editor. And I move this. Yeah, there we go. So this is doing exactly what I expected. And now we have to put physics in this and see how it works. I also need some way to move these things, because right now I don't have one. I can do it through the API, which is what I'm going to do for the physics test anyway. So I guess I'll just use the API to move the parameters. So first let's grab... Oh yeah, and it's going to annoy me about the settings there, the auto setup. I think it does that anytime you don't have any tracking, so we can probably just add something temporary. Yeah, let me just add a dummy parameter. So it shuts up that, like, you don't have anything mapped kind of story there. So if I reload the model... test model. Yeah, so it's gonna complain about that, and I can probably just add a I just add a... Hello? Like an auto breathing. And set the output to dummy. And that could even be used as a test for the pendulums anyway. So if I change the model now, is it going to save it? Yeah, okay, so now it doesn't complain about that anymore. That's good. Okay, so now let's see if we can get some physics in here. Now that's just JSON. I can just steal this from my... model here, and the physics 3, the model 3 has this is physics. Okay, so in the model 3 we have to set physics. And then this one you have to rename it. And there's no rename. He doesn't like that. So in physics 3, I don't even know if this matters, but you can just have, yeah, why does this have this much meta? That doesn't make a lot of sense. So I'm not gonna care too much about these right now. Physics dictionary, physics x1, okay, whatever, just delete everything else. I just have a single setting for now. Let's just say with one input and one output. And I think one vertex, 60 FPS. Okay, so setting one input parameter ID. We'll say this. I call them input 1 and input 2, I think. Yeah, ID input 1. So then this is the input 1, I think type X. Okay, so first of all, there is a spec for the options here. The JSON is publicly documented. Not what the parameters mean, like the math is not documented, but the schema is public, which is nice. So you can see that it has the... Like, it has some level of, you know, description of what the things are. It's not going to tell you the... It's not going to tell you the, you know, exactly how the math works, but at least you have some, like, a name for some stuff, right? There's so much silly things about physics. Like in VTube Studio, for example, it has like fixed FPS physics, and it's just like, you know, a real physics engine can have like a variable time step. Like this is like, you know, game programming 101. Like you don't need to have your physics run on a fixed time step, especially not when you don't need to have it be perfectly repeatable like this, right? Like when it's a game that is running like, you know, simulations that have to be exactly the same every time, you want to run it on a fixed time step. But for pendulums like this, you can just do a variable time step and it's gonna be fine. Oh, I already have a sturdy schema for some of these things. Not physics though, but I can create that pretty quick. Yeah, we could change the colors. No, but the thing is, I have the output. Like, VTube Studio will give you the physics outputs with 100% like full precision via the API. So I don't need to like visually inspect this. I will be getting the raw numbers. The visualization is just, you know, to have something visual for us to look at. That's why this is going to be not too hard, because unlike all of the deformer stuff I had to work out visually, I actually am going to get the physics outputs. So what I'm looking at here is input. Yeah, so that is type X or angle, right? Is the, and they didn't even set an enum here. It's just kind of sad. So basically the way this works, I understand, is that you have a pendulum, and when you have type X, it is moving the pendulum origin left and right, and that affects the pendulum motion. And weight, I guess, is just what gets added to that pendulum, right? So let's set the output to destination target parameter ID output 1. What is the possible target, actually? I wonder. If you have destination, it just says target type and parameter ID, but it doesn't say what types you can have, because I don't know what you can do that's not a parameter. Can you do like a part opacity or something like that? That would be interesting. I don't know if that's a thing you can do. I mean, we can look at the documentation. Actually, since we've been looking at the docs, let's look at the docs. Cubism editor documentation. So there is some stuff we can look at. Because not everyone will be familiar with this anyway. So the way this works, and you can see what they're doing here, right? Is that they have this kind of pendulum thing, right? And these are all the same parameters that are in the JSON, so there's nothing mysterious here. There's an about physics. And the group is sort of like changing for like stuff like the motion stuff. Angle X, angle Z, whatever, type position, angle, effectiveness, reflect. So these are the inputs. Ah, this is interesting. Okay, so the influence cannot be set for the same type to more than 100% in total. For different types, it can be set to a maximum of 100%. So that means that you can have parameters adding up to 100% as position X and as angle, but not more than that, which is kind of weird, but okay. I don't know that the position does anything interesting. If it's just being added, it should not matter, but we'll see if it does. And then, of course, the normalization would just be like a remap, I guess. Yeah, okay, that just means so I guess the input parameters are then added together, and then this is applied, which is weird because I would expect that on mapping to have an add for each individual input, but it looks like it doesn't. So that is, I mean, I guess it doesn't matter because it's all fine, but unintuitive. Among the normalized parameters, for this type of angle, one value blended with the degree of influences reflected in the angle of uppermost pendulum. Yeah, okay. And then you have this like change pendulum story, right? So the pendulum settings, it's just change vertices, and then they have these like duration, shaking influence, reaction time, overall acceleration story, right? So we have to map this into a function that does the same thing, essentially. it more computationally efficient that they're doing it? I mean, anything that is happening at the level of physics is going to be so cheap. None of this matters. Like, I think it's at the editor level, but it makes sense to have the settings be per input, and then it gets flattened out, you know, baked when you write out the file. But a lot of things are very badly designed in the UI of the Cubism editor, so... Yeah, so like this would be like damping, right? And then reaction time is probably damping on the input or something like that, right? And then ease of swinging is, I guess, like a multiplier on the input or something like that. And then this would be a change in the weight of the pendulum, essentially. See, it's like the smaller the value, the faster the swing, the larger, the slower the swinging. But like, the names are so weird. Like, this is clearly a physically modeled weight, right? But yeah, okay. And then yeah, I can do the rotation and whatever. So not 45 degrees. That's not why it's 45 degrees. It should be like 90 degrees. Anyway. And then the outputs can do apparently just parameters. I guess that value is only ever parameter. Automatic update of output maximum, pendulum number, okay, influence. This is just the ratio on the outputs, and there's a flip and the scale gets multiplied. Output maximum. Okay, so this is like a mapping to the parameter outputs. So it's just a bunch of mapping type stuff, so that's not very interesting. Yeah, okay. This is how like stuff like hair works. It's all done using the system. So, let's create a setting. So we have a setting, source parameter input 1, weight 40, doesn't matter. We'll do weight 100 because it'll be easier to find the formulas that way. Type X means it's moving the vertex left and right. I think you can see it somewhere. They probably have some examples. Yeah, so okay, that's the output settings. This is not interesting. Yeah, so this is X-type motion, right? It moves the top vertex left and right. So we'll have to try chains because that will tell us whether it's actually doing a full physical model or just like top to bottom. I suspect it's just top to bottom. But we'll see. Yeah, the friction coefficient should be static, I think. It's these things you said, but it'll be different for every pendulum in the chain, though. You can change all of them. So let's see how it works. So we have input 1, output 1. Let's just have a single input, a single output. Destination parameter, output 1, vertex index 1. I guess that's probably the first one. Scale 25, weight 100. I can possibly, let's see about physics. What's the range for those things? I have to multiply the calculated value by the swinging. It's not about the smaller the swinging. Okay, I don't know if this is relative to 1 or what. Doesn't say. Well, we'll try 25 and see what happens. And then type angle because it's an angle parameter. No, this would be to map a parameter angle to a rotation deformer angle, but that's not what we have here. What we have here is a X. And then we just need like one vertex, right? X, Y, 0. So this is interesting that they have this like position XY0 and then 015, because this kind of implies that you can have more, like the way I would model this physically is you have the length of the pendulum and then the weight, right? But in this case, it looks like there's no length of the pendulum anywhere. You just have like the coefficient of like, you know, the frequency effectively, and then the length only matters for placing the next pendulum, which is strange. Oh wait, no, okay, so there is a the 0th vertex is implied then, and you just add 1. So I guess we would have a single vertex then. But if you have it at XY0, does that even make sense? Because then these are different, right? You have mobility, delay, acceleration, and radius. Radius is... Huh? See, the numbers are completely different from what they have in the editor. In the editor, they have... They have duration, so ease of swinging is mobility, acceleration is no. Let me delete this and just see what happens. So if you reload the model, see if we get some physics in here. I might map it to the map. Oh, I did not like that. Okay. Is it because my JSON is broken? Don't think it's the commas. Okay, it doesn't like that. Huh, okay. If I take out the physics... Oh wait, no, why does it say it's broken now? It might be trying to load the physics anyway. I think it does that. Okay, so it doesn't like the physics. Let's see. Oh, I just closed Live2D Studio. Why keep doing that? Okay, so it does not like the physics stuff. Now, am I gonna get anything interesting in the Live2D Studio log? I wonder. Right? No. It's snooping at all my key presses, which is annoying. Okay. So, not Live2D model. Oh, JSON parser. Okay, so it's literally parse error. The Model 3? Did I miss up the Model 3? Oh no, physics 3. Okay, yes, I messed up the JSON here somewhere. Ah, that. It's always... I hate that JSON thing. Yeah, it's still broken. Oh, it's telling me. Sublime is nice enough in telling me that I'm... Wait, there's a little marker on the left. Okay, there we go. Now we have physics. So how about I map, for now, it's just a test, the first input to the mouse or something, so we can move it? Yeah, that's not doing anything. Also, how is the mouse so off? Because from -1 to +50? What kind of range is that? It's like based on the screen or something. Okay. Anyway. Let's do a remap there so it's less crazy. Oh, and on top of that, it's doing a smoothing thing. Yeah, let's not do that. Okay, so that's okay, so it doesn't like the physics inputs, or it didn't load the physics, or it didn't map it. Okay, so output 1 parameter, is it actually recognizing that this is a physics mapped parameter? No, it isn't. So it did not actually like that. Okay. Yeah, that's why a JSON format and state thing. Though I'm mostly going to be changing numbers and not adding and removing things, so it's not a big deal. Okay, so output parameter 1, vertex index 1, does this need to be 0? No. Let's have 2 vertices. Nope. Okay. Now it says 1 is a physics parameter, so it found something. Okay, now at least it found it, so at least it's there, but it's not moving. Okay, now it's still... Yeah, it likes that. Okay, let's try vertex index 0. Is my physics turned on for one? Because I might have turned it off for reasons. I do have turned off. Let's turn off dragging and I set this to 60. Okay, so it is set to use physics. No, now it's not set. Hold on. Let's just do a grab there. So now it says the one is a physics parameter, but it's not actually mapping it. If I set the vertex index to 1, okay, so it needs to be vertex index 1 for it to do anything. Do you have a plan right, or you figure it out as I go? I mean, it's reverse engineering. You kind of have to figure it out as you go, right? I do not have programming socks on right now. Just regular socks. Okay, let me look at the original physics setup here. Sublime. So it looks like vertex index 0 is not used. What's it? Let's find a simple physics setup. Looks like you always need to have 2 vertices, but then I don't understand what these settings are for if the first one is like nothing. It probably needs a radius, that's probably why. Okay, still nothing. So here's one with, yeah, acceleration, mobility, and then position x, y. Set this to 10. T1, delay 1, acceleration 1, radius 10. So this is a valid setup. So if I stream the parameters... Oh, actually it's doing something, but very little. Okay, that makes sense. So you can actually see that it's doing a small change very briefly. So it is working. Wait, no, this is the input. Hold on, that's the input. I'm dumb. The output is all 0, so it's not doing anything. So... Huh. Well, I can set this to angle just to see if it does anything. Vertices, position, mobility. 0.9. 0.6, maybe 1 is silly. 0.8. 0.9. 0.6. Radius 10. That should be a valid setup. Ah, there we go. Now it works. Okay. And it's backwards. Let's change this. Okay, so now what it's doing is it's mapping the angle of the pendulums to the output parameter, which is why it always goes back to 0. So do these do anything on the top vertex? Doesn't look like it does much. It shouldn't do anything on the top vertex, right? Like, if I set ridiculous values for everything. Yeah, I don't think this does anything. I don't even know why there is a top vertex. I think it's just the file format is silly like that. Yeah, we'll have to test if there's any difference in the output, but I don't think there is. So this should be a single pendulum right now. Because I think this is just literally the input vertex, right? So now if you change the output instead of angle to X, it should not return to 0. It should be following the X position. Okay, so now it's not doing anything. But it probably needs a big scale. Oh, it doesn't do anything, okay. Nope. Does it need more values for mapping an X position than an angle position? If I do an output reflect type weight scale vertex index. If I set it to 0, does it do anything? I think if it's set to 0, it doesn't do anything. And angle. Yeah, it doesn't do anything. And so let's make sure this works. Yes, now the scale is huge, so it's running off. What is the position to X at 10 there? Nope. Is it streaming anything? Nah, it's absolutely nothing. That's interesting. And there's a normalization thing here, which is for the input or output. Is it possible that type X is never used in outputs at all? Well, it seems to be used in inputs in the demo. Maybe it just doesn't work. Output settings. Oh yeah, there's okay, that's just not a thing. Why is Live2D so chank? So literally the angle is the only thing that can never be an output. Okay, that's not very nice. Yeah, it's the angle. In radians. Okay, this actually tells you how this works. It's the angle in radians multiplied by the scale. Python watch where you can load the JSON. No, the JSON is being loaded into Video Studio. I mean, I could add a watch, but okay. So we have something here. Let's see if we can make sense of the math, right? So we can stream the parameters, and we can stream them and set them, and we know that it runs on a fixed time step, which is very convenient for us. So I'm gonna take off the mouse mapping here. There's no reset. Great. Well, we have let's just set to like output 2, whatever, doesn't matter. Can I just delete this? Wait, what? I deleted it. Why is it still doing it? Oh my god, V2 Studio, how are you so jank? I know, that's just... Okay, this is hiding, not deleting. Okay. There's no disable? Input. Nothing. Okay, thank you. Hi. Okay. So let's give it a... first of all, if I change these patterns to 1, does it break it? I guess I do want to test a little more with a mouse. Or I could use auto breathing even. And change this to input 1. Interesting. You can see the natural resonance there, kind of. I guess there's no breathing speed set here. Whatever. You can see that it's moving. It's also glitching sometimes. So if I set acceleration to 1 and radius to... If I set everything to 1... It does work. And then the wipe... The X position being different here is what changes the startup state, I guess. That's not what I want to do. If I reload... And I guess the breathing is gonna, like, probably alter that. Hold on, if I set the input to nothing. Turn off auto breathing. Hello? So. Yeah, okay, so if you start at 0, it starts at 0. If you start a 10 or whatever there, it's probably just gonna, like, clamp. Oh, no, it doesn't actually. Okay, yeah, then I don't know what the X position here does. Possibly doesn't do anything. Okay, let's turn the breathing on. And maybe set the weight larger so you can see the movement better. Sorry, not the weight, the scale. That is very glitchy now. Oh yeah, I remember. So first of all, they have a weird multi-threaded physics thing, and I bet it's broken. What we need to do is change the physics to use app FES, which then is what we want if we want the thing to be predictable. Yeah, see, it's not glitching anymore. Why is V2 Studio so janky? Okay, yeah, so that at least is doing a, you know, it's doing what you expect with an input and an output like that. And now does position do anything for these? I don't think it does. So right now it's moving from about 2 grid ticks, right? Yeah, quite frankly, I don't think these vertex positions do anything, because it is literally just adding the radius to each one of the previous ones. I don't think this does absolutely anything. I think this position is just completely ignored. I don't know why at the beginning, though, it does that. Like, it jumps around like that. Is it just because the breathing parameter... Yeah, I guess it's because the breathing parameter gets set instantaneously and that, like, glitches it. Yeah, I think these position parameters are completely ignored. The VTube Studio thing is running, like, physics on a thread or something, and it's very weird. Okay, so if I increase the radius, though, that should definitely change something. Yeah, see, now it's much slower. So that is the length of the pendulum, right? What they call radius. And it's not very stable yet. But I think that's normal for the kind of motion we have. It'll because it's a mix of the input. Yeah, when the pendulum zone speed is slower than the input breathing thing, it's going to do a motion like this. So let's now let's just set it to 10. And the other parameters that we have, let's see if there is a like sort of no-op setting. Because, for example, we don't want friction until we get some of the other things worked out, right? So we have duration is the speed of the swinging. That's oh gosh, it's so weird. It's mapped differently. What we actually have is shaking influence mobility, delays reaction time, speed of convergence is 1. Which is what? What is that? Acceleration? Well, let's find out, because when we set something to 0, something is going to make it swing forever, right? Yeah, okay, so now it's very, very crazy. I think now it's just never stops. So if I set the breathing weight to 10, I guess I don't really want breathing. I guess what I really want... Okay, let's go back to the mouse here. Oh, okay. So now it's actually not moving at all. Okay, so this is stopping the physics. This is just moving the pendulum. This is stopping the physics. Okay, so acceleration is like how fast the it's basically gravity then. Acceleration is gravity, and then there's like no okay. Okay, let's make a notes file here for now. Let's actually save this to Mox Fury. We are figuring out how physics works in Live2D, and as kind of expected, it is kind of weird. Okay, so if I set mobility and delay to 0, what's gonna happen now? Okay, yeah, so those don't do anything as long as acceleration is 0. Oh, but that happened. Woo, interesting. So it kind of works and then it completely glitches. Interesting. So mobility to 1. So like when it goes over the top? Yeah, mobility to 1 does that. Okay. And then delay to 0. Yeah, it doesn't do much as long as acceleration is 0. So with acceleration 1, still doesn't move much. Uh-huh. Oh, no. I mean, I do think this is going to be simple to implement, but we just need to make sense of the inputs. Like, once we understand the mapping of the inputs, I am pretty sure the actual formulas are going to be very simple. But the tricky part is, it's simple to implement. The tricky part is figuring out what they are. I didn't say this was going to be a really quick stream. Those are two different things. So, okay, if we set delay to 1, okay, now it's actually converging towards 0. Slowly. So delay seems to be the actual, it says reaction time. And then mobility, oh gosh, these names. Okay, so now it's acting as a pendulum, right? If we set the delay to 0, that sounds like it should make it swing forever. No, it doesn't do anything. Okay. 100? Okay, then it just doesn't move. Let's give it more scale. Okay, that's very fast. So, delay 1? So it looks like delay here is actually the inverse of the weight? No, wait, not weight, because the weight only affects the pendulum speed only depends on the length, which should be the radius. Then why is it going faster when I change what is called delay here? This might be changing gravity. This might be changing gravity then. So if delay is 0, keep clicking that. Yeah, okay, delay sounds like gravity to me. There's drag of some sort because that's why it stops to 0, right? So mobility is... I set this to 0. Is that the one that is gonna make it not converge? It's the opposite. So that's like more drag. That is so strange. Okay, now it's definitely... Oh, okay. I try to get mouse cursor close to 0. Okay. Then it doesn't do anything if mobility is large. What? What did they do with the math here? This is ridiculous. I set acceleration to 10. What does it do? Oh, that's faster then. Acceleration maybe, and then it's gravity, because that would actually make sense. So if I set acceleration to 0, then yeah, okay. I think acceleration is gravity, because that makes sense, right? So acceleration is gravity. But the interesting thing is that means that when you move the input and the pendulum is moved, if there is no gravity, isn't it supposed to keep some kind of speed? Or actually, I can't think of this model. In the no gravity model, if you have a pendulum and you move the origin, yeah, I think it wouldn't actually add momentum to it. In some models. So I think that gives you a hint of how it's implemented. So acceleration is gravity, okay. Then what's delay? Oh, that's interesting. It's literally a delay? Huh. It just stays there. But it's clearly not just delay. I feel like a delay might be like a kind of speed of the simulation. Like a time step multiplier? But they need to figure out the damping though. So what's mobility? Okay, that looks like friction. So mobility 0.1 is making it much slower. What about 2? Is there like an inverse thing going on here? Oh, that looks kind of interesting. Okay, I think anything over 1 is making it unstable. Yeah, looks like it. Ah, yes, anything over 1 is making the motion keep increasing. Okay. So then mobility 1 should not be damped, though. That's interesting. Is there another fudge factor? Live2D loves fudge factors. Maybe they have a thing where like it's never undamped. This is gonna be another fudge factor, isn't it? Yeah, see, like 1.1 is... Yeah, they definitely have something here. I bet it's like 1.05 is undamped. It's still a little bit damped. Okay, that's not damped. It's just one of those things where they let the user control it from 0 to 1, so it's never crazy. And then there's like, it's just an offset. See, now it's going crazy. Did I just find it? No, it's going down a little. Now it's going up a little. Now it's going down a little. That's looking pretty close. I think it's actually growing very slowly. Yeah, it's growing very slowly. $65? That's actually a reasonable number, floating point wise. I feel like it's going down a tiny bit. It's going up a tiny bit. It's going up. I wonder if I can make this. And I wonder if this is actually the same no matter what the other parameters are. Yeah, it's going down now. Still going down a bit. Still going down. still going down. 6 to 8. I think it's the only damping factor. Well, sometimes it just gets lower. I think there's also just some like bugs in the physics where like it skips frames and then it's, you know, the simulation isn't really correct anymore. Okay, let's see what happens if I set the delay to 1, for example. Is it gonna change something out of this critical factor thing? See, when I start the stream, for example, it loses time, right? It loses momentum. So the physics isn't even correctly accounting for like dropped frames and stuff. Ah, but now it damps. See, now it's different. So it's actually a combination of factors. It's not that that is a fudge factor just like that. There is something else going on. Oh, wait, hold on. Yeah, because delay 1, acceleration 1, radius. Okay, so if I set it to that. Oh, now it's growing forever. Okay. Okay, so now it's damped. Huh. And sometimes it just stops. Great. What's that? Oh my gosh. This is so ridiculous. Now, I think I'm slightly moving the mouse. Okay. Set the radius to 1. It should be a lot faster. It's still damped. Yeah, so for example, at this setting, it still does this. The thing is, it is possible that this is just damped naturally by like the frame rate, and so we're not gonna make sense of this damping behavior in terms of like basically the simulation might just be bad, and so even though mobility 1 is supposed to not damp, because actually I think mobility is this one then. Possibly is the ease of swinging, because I say the ease of swinging was from 0.7 to 0.99. Because speed of convergence is actually backwards then. Okay, now I really want to know what these settings map to, because this is like the naming here is ridiculous. Reaction time over acceleration, radius of pendulum, shaking influence, mobility, and then reaction time. But what's reaction time? So okay, reaction time is the thing here. Reaction time is delay. So delay 1 is standard value. At least that one they use the name. Ease of swinging is like shaking influence, I guess. Duration. So okay, duration is gravity, right? But then, hold on, the smaller the value, the faster the swinging. That doesn't make sense. Okay, I think this doesn't mean reaction time, this is the time step. That makes sense, because it literally says if you want to change the speed without adjusting the amount of change in the parameter value, adjust the reaction time item. That would make sense. That the reaction time is just a global speed setting, basically. So delay equals reaction time equals time step. Acceleration is gravity, and then which one is that then? So acceleration is definitely gravity, but then which of these parameters is it? Speed of convergence? How distribution of physics is worked towards a certain particular animation needs. Okay, as a rule of thumb, Live2D are not very smart about designing their systems for VTubers. Don't assume a lot of thought has gone into some of these things. A lot of everything in Live2D is like janky and kind of not very engineered. Like some of the things, some of the weird like magic numbers they use in some places are just ridiculous. Was this made in Japanese? Yes. Okay, so mobility. And then we have okay, radius, this is radius. Wait, where is the radius set? Hold on. Mobility, delay, acceleration, radius. Well, it should be obvious to see which one is radius by looking at how it's influenced by the... Okay, duration is radius. Great. And hold on, acceleration. Then acceleration is not duration. Hold on, duration is radius. Ease of swinging is looks like delay. No, reaction time. That could be time step, because if the time step of the simulation is... actually, I'm not sure. So acceleration is gravity, which means okay, ease of swinging sounds like this is the damping. Yeah, the ease of swinging is the damping. Which I think is mobility. And then reaction time, that would have to be gravity. And speed of convergence has to do with the damping. Yeah, I think reaction time is gravity. I think. Either that or duration. Hold on, duration is... No, that's the radius, yeah. Because they say if you want to adjust speed without adjusting the change in parameter, adjust the reaction time thing. But that's a lie, because you can see right here that with reaction time set small, it does change a lot more. So it's not a time step. So then delay would have to be speed of convergence. The convergence is equal at 1. What does that even mean? But this is backwards though, from what we saw. Is it? No, actually no. Mobility is what we saw. Mobility is ease of swinging. Okay. But this is damping though. Ease of swinging is clearly damping. Because these two look like they keep the same, like, frequency? Same period? Which means it can't be gravity? I think reaction time is acceleration. So then this has to be delay has to be speed of convergence then. And then mobility is what they call yes, it's actually inverse damping, right? So it would make sense, given also the numbers that they give here, right? That ease of swinging is a linear, what do you call it? It's like a one-pole filter coefficient. And then the fact that you have to go above 1 to make it not converge is probably just an artifact of their simulation being kind of bad. essentially, what mobility probably is a damping, I bet it's a one-pole filter on momentum. I bet it's something like that, what mobility is. And so that's the alpha. Is how I would do it. Let me make a note of that. Radius is obvious. And then assuming acceleration is gravity, which is reaction time. I think that makes sense. Because if gravity is stronger, it'll keep it more vertical like that. And so then what's delay? Delay is an interesting one. This might be on momentum or position. Because I think the way this became here, it makes sense that it's a one-pole filter on position. Or angle, rather. Yes, and then the mystery is the speed of convergence thing. That might be a time step, though. Because if I set delay to 0, it doesn't move at all, right? And if I set delay to like 10, it just like resolves very quickly. So this might actually be a time step multiplier. That would make sense. If it is a time step multiplier, it should also affect the speed. Even though here it looks like it doesn't. But let's see if it does for me. If I make the weight larger here, and just see how it okay, it doesn't do much here. Oh, because I did say set mobility to 0. I just set that to 1, so it doesn't actually do anything there. Okay, so it's still not enough. Oh, no, wait, sorry. I need scale to like 25. Yeah, it's just like... Seems to be very, Yeah, it jumps around and goes to 0 very quickly. Okay, now it's not... Why is it damped? Damping is... Mobility is supposed... Whoa. What am I doing there? That explains that. Okay, it's now... Okay, so now it's swinging, right? And sometimes it glitches, but okay. So if I set delay to like 2... Yeah, it's faster, right? Everything is faster. And if I set delay to 0.1... let me see if I can reset it a little. Get the mouse at about 0.5. Now it's very slow. Okay, try 0.5. Yeah, it looks like about twice as slow, right? So I think that's possibly... Yeah, that kind of looks like a time multiplier, right? So delay speed of convergence is actually a time multiplier. So that kind of makes sense. So we have a time multiplier, gravity, the damping, and the length of the pendulum. Those are parameters that make some sense. So let's set delay to 1, acceleration to 1, radius to 1, mobility to 1, which means undamped, and then it's still gonna be damped somehow, which is questionable. Unclear why. Possibly just simulation inaccuracies. What happens if I change the physics settings here? Sometimes it just breaks, as silly as that is. Like, sometimes it just stops. Why? What? It just stops. Does it like hit a Nyan or something? Look, sometimes it just stops. It's like it hits a Nyan on velocity or something like that and it just like breaks. But why would it do that? I haven't even set any crazy parameters here. Is it because the mobility is 1? Oh, look at that, look. See, at 30 FPS, it converges towards 0 fairly quickly. At 120 FPS, it takes much longer. So I think this like undamped convergence thing is just an artifact of the engine. Like, just because of precision issues to the time step, it like has built-in damping basically. And if we set mobility to like 0.99, which is actually more reasonable value, is it like not gonna Nyan this time? Yeah, I think the weird nanning happens when you set mobility to 1. Yeah, at 120, it goes way longer. So they just have a fairly bad simulation that, like, damps... Oh, it still glitches, even if I do that. This software is very well designed. Because naively, you would think if you increase the FPS of the simulation, then it should actually, everything should run faster, right? But it doesn't. It actually takes longer to converge. Which tells me like, they are in principle, they are in principle, like, taking into account the FPS of the simulation, but then they're, you know, the error in their formulas means that it damps implicitly. Well, we're gonna set to match FFPS because that's the only one that doesn't really do weird stuff. Yeah, the NAS might have to do with the multi-threading thing. Kind of looks like it. Yeah, at match FPS doesn't do the glitching anymore. So we're just gonna do that for now. So what about 1 here? Does that confuse it? Yeah, it doesn't get stuck anymore, so the multi-threaded physics are just quite broken. Jank, 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 jank! Yeah, it could be divided by 0, but like... I think it's a multi-threading thing. Because it doesn't do it at match FFPS. Anyway, okay, so we have something here. Let's have all these at 1. And see if we can reconstruct the formulas. So we have position minimum 10 default 0. This is are these the input or output normalization settings? I think output maximum here is just a display thing. Yeah, this is the input normalization, right? So, the position ends up being -10 and +10 on the input. Yeah? You okay? Oh, what's going on? You okay? Cyan! Hello? Yeah, I'm kind of hungry. No, I was checking to see if you used to read something. You okay? Okay. Yeah, that's okay. Thank you. Okay, so I think we have something now. We have an input mapping, and so this should move it by 10 if we input 0 and 1, I think. And we can test that, so seeing how much it moves with the mouse. So if I do -1 here, yeah, it moves a lot less, right? So this is just a mapping. Let's just set it to 1 so it's easier to work with. And angle should do nothing because we're not mapping anything to angle. Oh, it stopped there again. Okay, so we have something now. We can create one for the bottom one and use it to feed it, so I don't have to keep resetting my mouse settings. Actually, I'm just gonna change the parameters. So let's set this to input 2 and output 1 is fine. So then we can change the input programmatically. So now let's copy stream params and let's copy that to physics dump.py. So then what we need to do is give it a set parameter thing. Maybe this does have a set parameter, I think. I'm not sure. Some of it is not really configured. Set parameter value. So the parameter, we can just say input one. I probably need to have a custom parameter or something like that set. So let's do I think it's using input parameters, so we can just say like math x or something like that, and map that to input 2 is fine. So I know these actually let's do the let's just do def dump params. And we can just put this in here. So we can just do await dump params. And then we don't need to do this long. So for I in range 10, await dump params. And then await bts.close. And we just have a few frames is enough. Where is this request? This is in VTS request. No. Okay, there we go. So now we have 0, and then I want to have a time on here just to make sure I you know what time we are getting the responses from YouTube Studio. Yeah, you can see it reset when the time's out, right? Let's see. And let's actually do a time, and then t2 equals time, and we can just print t2 minus t1 and t2 minus st. Okay, so you can see that the first request actually took longer, and but it was. Yeah, this is small because that gets run immediately after ST. So that makes sense. let's multiply everything by 60 so we have some kind of like frame count thing going on. Yeah, so these all come in with 1 frame difference. Let's do a this is the time. This is the duration. And time equals T1 SSD times 60. The time. So C time. So there's a weird offset there where you have like a half frame difference. So see T2, we actually get the response. Okay, no, the response is not a frame. Okay, so we are losing 1 frame when we request the. Basically, every request takes 1 frame because VTube Studios is weird like that. So I don't think that actually awaiting really biases anything. If I don't await, I think if I try to pipeline the request, it's probably not going to work anyway. So essentially, we need to consider that there are probably 2 frames of motion involved here. Now, what I don't understand is why is input 1 here? Hold on, is there smoothing involved? Yes, okay, no, I don't want that. Yeah, so input 2 here is the one we care about. So let's actually grab these out and print them nicer. So we care about output 1 and input 2 right now. So input 2 and output 1. Okay, so that is clamping. So we want to make this a little less. Let's make the change a little smaller. So 0.5, for example. Yeah, that's better. But it does hit a 0.99 there, which bothers me a bit. So let's do a 0.25. Oh, interesting. So it's exactly minus 0.5. That is a very interesting number. That's not a coincidence. And you can see actually how it's decreasing. Look, the number, that is not a coincidence. The numbers there are very round every frame. That is good. That means we can probably figure out what's going on there. I like that. I like that. So the output, the interesting thing, okay, this is already kind of sus. The output is set to angle, the input is set to X. I set the input to angle, actually, let's give it as X, because I like these round numbers. This is very interesting. So you already can see the first 3 time steps. The outputs are actually, let's actually round this because I was not expecting it to come up with round numbers, but it is. Let's try 0.5. Let's try 0.4. Yeah, okay. Still not quite rounding, but we can 0.3 and see that. Yeah, so that's very interesting there. I mean, a similar engine is good enough as long as it's close enough to similar, you know? So look at the deltas and angles here, right? What we have here is a I'm actually gonna print it last. This is already weird. Why is it changing by a smaller amount on one frame than the next? The fact that these round numbers exist tells me that there is no like the gravity 9.8 type of deal. This is all using, you know, like simple integers, so there are no weird magic numbers, which is nice. So now how do we make sense of this? And also no, this is supposed to be in radians. But even though it's supposed to be in radians, it is somehow a round number. Huh. I think I might need a cough drop. My throat is being really silly. And now I can't find them. No. Oh yeah. Oh, so cute. Thank you. So discreet, it's so analog. Yeah, so like what's going on here, right? I would like to see this one frame we're missing here. Is a little sad. But it might not have one. So if I set it to 0.3, for example. Okay, like it's minus 0.6. So now we know the input and the output are being mapped in a very obvious way here. And that's where you get the 1, right? So that's really weird because this is supposed to be hitting the x-axis, but somehow it is affecting the angle by. Okay, hold on. There's one more thing I need to check here before we continue. Go back to input 1 and give it a reload. Okay, so now we're back at the mouse control. So this is supposed to be x-axis control. What's the difference between x and angle then? Oh, angle doesn't do anything. Great. So the inputs are always x, and the outputs are always angle? Not what I want to do. Yeah, I guess. Hold on. So the inputs are always... No, there's position and angle. Hold on. So if the input is of type... There is an angle thing. Maybe just the weight is wrong. Okay, it does... Oh, okay. So the... Yeah, so this type is the one that like makes it stay in that point, right? So, okay, so if this is an angle, then I should be able to like multiply it by... If I multiply it by 10, because this is a pendulum, it should do some weird stuff at the top, right? If I exceed like 3.14 on either direction. Great, no, it's nothing. Is it the other way around? Does it need to be minus 10 plus 10? Yeah, I think so. It kind of looks like this just offsets the entire angle of everything. Yeah, I guess this just offsets the entire pendulum. Essentially. It's like rotating the whole thing. So then if I set it to like -1 to 1, it should be a parameter range of -1 to 1. But it's not. It's like 0.5 because I changed... Wait, the output is scale 25. Okay, the output is scale 25. That's a big number for angle. Is the scale out of percent? Like a... Okay, hold on. And then it glitches. Great. Interesting. Tilt in the z-axis direction. Yeah, that's what angle does. So, oh, sorry. There has to be a some kind of radiant thing going on here. So the output is scale 100. All the weights are 100, and this is the angle, and then somehow we have a. This is some kind of, hold on. So this is setting 100 at. Minus 0.57. Isn't that like a quarter pi or something? That's something. That's some kind of number. No, that's 0.78. Okay, I guess, let's try 0.5 and see what number we get. Yeah, close enough to 0.5. What is this number? This has to be some meaning to that number. No, actually, I have a better question. Do any of the physics parameters influence that number? So we're hitting about 0.57 on the edges now. If I change, for example, the delay and the acceleration and the radius. No, that's the same, which is what I expect. This is just a angle offset, so the physics parameters don't matter. So it's 0.573 is when the output is -1. Ah, 1.8. Well, that's a suspiciously magic number. I bet there is a constant there for something. Like a built-in, a built-in something. Oh, wait, is this 180 degrees? Is something in degrees here? Something is in degrees here, isn't there? Because I have the scale set to 100. Ah, okay. So if the input is an angle in degrees, then 0.573 degrees divided by 180 times math.pi gives us radians times 100. There you go. So the input is in degrees, the output is in radians. Because Live2D is very intuitive. So that does mean these are radians, and somehow that input x value is affecting the output in a round number of radians. So let's see if this makes sense. We have a position, because some of these, no, it doesn't make sense. The output is in radians, and yet the input is not in radians, so then is the input scaled in a strange way? Is the input adding? Like, instead of being x-axis based, is it like is there like a function applied to make it remap to radians? Very interesting. Okay. So I guess first maybe we should work at the angle mode. So if we're working with angle mode, we can just say 90 degrees and get some kind of like useful number out of it. And so we know the output angle should be starting at 0 and then getting close to 90 in radians. And so if I set the scale to 1, it's actually not, it's going to be too big actually. Okay, so now let's change the input to, we were saying it was input 2, I think, for the control. So let's reload that. And then for physics dump, it's actually make this a little longer so we get closer to the convergence. $157. What's 157? Okay, so I said it's like 0.25 or something, right? So if I make this 1.0, it should be too big. Yeah, it's too big because it's mapped as radians. Okay, so 0.5, so 45 degrees. Yeah, there you go. So 785 is what you get there, and that should be yeah, that's what you get. Math of pi divided by 4. So we know the angle starts at 0, and then, like, instantly gets... The pendulum basically gets instantly jumped to 45 degrees, and then we have this progression, right? So I'm going to take a very quick break. I'll be right back. Now we're going to start looking at formulas and see if something fits this. I'm back. I think Cyan's gonna join me for lunch, maybe. Okay, let me check the chat that says some stuff going on here. So looking for exact reproduction or good emulation. Okay, I am looking for essentially, how do I put this? A visually indistinguishable reproduction, except for making it work better. Because there are some blending issues with the... VTube Studio is kind of broken in some ways. Like, for example, you probably can't really tell, but there is, under my eye here, a little line. That doesn't show up in my renderer, because VTube Studio doesn't do texture sampling properly. So I'm not going to simulate bugs like that and like really dumb things. But other than that, I'm aiming for essentially something that looks indistinguishable, including the physics. So it doesn't have to be like, exact to the infinite decimal places, but it has to be essentially compatible. Hello.
Hello. Do you welcome me?
Yes. So you made me lunch.
As I always do.
Thank you. So we just discovered in Live2D amazing things. The input numbers to the physics engine when it's an angle, the input is in degrees, the output is in radians.
Eh? How did it work?
I mean, it works. You map it however you want, but it's like
You have to convert it.
the numbers mean different things on the input and the output. This is very well designed.
I actually have a question.
What?
Remember in VTube Studio, there's like an expression tuner.
Mm.
It goes from like 0 and 1.
The
0 to 1.
The physics or the
expression.
Yeah, the expressions you can set them to. Sorry, which one are you talking about? You mean this? Yeah. Like you can create them, right?
Yeah.
Yeah?
Yeah.
So this is kind of stuff, right?
Something like that.
Uh-huh.
But how do they map everything to 0 to 1?
Oh no, this is set by the model. It doesn't have to use 0 to 1. This one is minus 1 to 1, for example.
Okay.
The model does that. It can be any range. Like the person who rigged the model decides those ranges.
That makes sense.
Okay. Itadakimasu. Did you eat already, by the way? That's not what you said. But the person we released anywhere, it already is. It's called Ayagami. Let me show you actually. Not this one, but actually. So there's a web demo you can open and you can drag your model in here and it'll like show it to you and let you tweak it and stuff. But it doesn't have physics yet, so that's why I'm doing this. Is physics important for VTube Studio? I mean, look at my hair, right? Everything, all the hair and all that, all the motion is done with physics. But the physics engine, as we just saw, only has a few parameters. It's pretty simple, so I don't think it's going to be very hard to replicate all the physics. The physics settings are in the models. So once you have the algorithm for the physics engine, it should work the same.
When? Can I open YouTube?
Please don't play music. Yeah, music computer.
Am I muted?
Not the microphone, but the computer.
The computer is muted.
Okay, good.
Did you tell them we're gonna debut?
Not yet.
You forgot.
I was gonna tell them at the end. Because that's when I get most people.
Okay.
But we can tell them now.
I think we already told them.
Hmm?
I think we already told them.
that we are re-debuting.
Yes! Yeah, yeah, yeah!
As Tokyo Hacker Girls
Yeah, yeah, yeah!
on August 1st.
I'm actually government programming from Lina. I'm nervous.
And we have new models.
We do. Can't believe we do. Something you want me to work on today?
Hmm?
Something you want me to work on today?
I don't know.
I want to go to the Stan Gates things with you. I tag you and I was like, I want to propose to you there, and you did not respond to me.
I'm sorry.
I see.
Is this game ending like physics? No, it's a very simple, very limited pendulum chain thing. That's all it knows how to do.
I see. Me dad. Argentina's blue flag.
So I think as a tech programmer you just joined, we were just talking about the input and output. When there are angles, the input is in degrees and the output is in radians. Because of course. Everything is so jank and strange and like not really designed.
Are you sure you're supposed to talk in public about how other people's code work?
I mean, we just found that out. What do you mean?
I know, but like, you know, you can be a little softer on it.
But everyone knows Live2D is jank.
Oh, come on. I don't want to get a lawsuit from them.
You're not gonna get a lawsuit from an opinion. You just can't say lies. Like... Come on.
Okay. I think Live2D has collision, right?
No, it doesn't.
Eh, well? Ah. Then also like Twitch emoji dropping since hitting people's mobile.
VTube Studio itself might have some collision thing.
Also,
But that's not part of Live2D.
I figured. I don't know if it's relevant, but do you know how hand tracking works? On the Live2D side?
I mean, it's all parameters. So...
Nothing special?
No. If you whip the pendulum chain not the self cloud, I'm pretty sure it doesn't, because it's the connections between the pendulums are stiff, and I'm pretty sure they don't have any kind of collision with those. So.
I'm going to post our debut announcement on my channel. Do you want it to?
My channel?
I'm just saying that's why I'm going. You finish it? I'll bring it up. Up. I have 345 videos. Can you believe?
Ooh, that's a lot.
No, it's a good number. I have 100k subs and 345. How many videos do you have? Lena, you have 51 videos. What?
I used to have more, but a lot of them got, private.
Oh, you're right. But like, I also have lots of shorts that doesn't have much of a meaning.
I don't use reverse engineering binaries. Ghidra usually. This project doesn't have any reverse engineering at all.
Eh?
Any binary reverse engineering.
Okay. So doesn't. じゃあ、行ってきます。Call me when you need me.
Okay. Alright, let's see. Impacts was for the file format reverse engineering. For binary, this person said binaries, I think they mean executables. That would be Ghidra. Okay, one thing I was thinking is since the inputs are in degrees and the outputs in radians, let's give it a round number input in radians because it's going to be much nicer to see. So for this physics test, instead of giving it a test physics, because I get confused. Physics dump, this one. Let's just say value equals 0.5. So in this case, we have the mapping we have is input. Let me remind myself. Everything is scale 1, and the input is from -90 to 90 degrees. So actually, let's do from -180 to 180 because that's exactly pi radians. And then let's reset these to 1 because we want to see nice numbers. So then, if we set the value to 1, it would be 180. Now the output is in radians, it can't exceed 1. You know, maybe we should fix that. Let's fix the output clamping, because it's going to be more useful that way. Let's have the output have the full range all around, which is from -pi to pi radians. And because this is in radians, actually no, I can just make the output really large because we're going to get the raw parameter value anyway. So if we just change the parameter key points from like 10 to -10, actually no, that's too much, but we want pi to pi, so just say from 5 to -5. It's just going to avoid clamping, which is what we want. And then the key points, we can also make them -5 to 5. And so, just ignore the trolls. So, this is Sublime text. So if you make this an hold on, let me just don't react to the trolls. We'll take care of it. Don't worry about these people. It took me a word to pause the chat. Can you tell I haven't... Oh, channel level settings, is it? No, hold on. Can you tell I haven't had to deal with this very often? Usually these people get bored very quickly. Yeah, don't worry about the, like, seriously, don't worry about the trolls. Like, don't even react to them. Can't believe I can't find the, like, subscriber only chat. Yes, that is Sublime Text. Ah, I think I found it, okay. Yes, it's suddenly in slow mode, so hopefully that that's a little easier now. So if you stop for 5 minutes, you can talk. So anyway, back to this. So let's see. We wanted to set the value is from 0. It's set to pi radians. So if I go and so if I set this to 1 over math of pi, then we should be getting 1 radian exactly. And let's see if the number is nice. Okay, so it's 0.5 on the output, so I have like an off by 1 somewhere. Did I reload the model actually? I didn't remake it though. So it should be from minus 180 to 180, which would be pi radians. And all the weights are 1. I don't think any of these numbers do anything different. Just to check. Where's my 0.5 factor going? I might be able to change to slow mode. Because slow mode is per... it's per person, right? Let's say the 10 seconds, actually. So, why am I having a 0.5 factor somewhere? The physics is mapped from, actually, the output is just weight 100, which should map directly. Scale is 1. Maybe the scale is halved. Maybe the scale means from minimum to maximum, and so because the range would be 1 to 1. No, that doesn't make sense. The model has param from -5 to 5. If I set this to 10, it shouldn't change. Then this is just a range, then, right? Yeah, that doesn't change anything. It just changes the amount this is going here, I guess. No, it's still 0.5, yeah, because the mapping is the same. The key points... No, hold on. The key points are -10. Did I... Why is it still -1 to 1, actually? Oh, because I'm not reloading. Hold on, so let's reload. Because I had the menu open. When the menu is open, it doesn't reload. Yeah, now it moves just a little bit. Okay, now it's 0.1. Okay, so it is scaled by the parameter value somehow. So somehow the output in radians is being automatically scaled to be within the range of -10 to 10. So if the parameter is -1 to 1, yeah, no, wait, still 0.1. What? I didn't reload. Yeah, now it's 1.0, which is what I expect. So it is scaling by 10, which, like, fine. We can work with that. At least we get round numbers. And I'm guessing the key points then don't matter, just the parameter limits. Yeah, just the limits matter, okay. So then what I could do is change the scale to ×10. And then that should give me round numbers. Yes. And then it actually goes above 1 because it can. Okay. So essentially what we have is... there's something interesting about the minus to plus, though, how they're doing that. What happens if the parameter is set to... if the scale is max 10, minimum... What happens in that case? And let's go back to the scale being 1. Okay, now it's always 1, so I think it's probably scaling within the range. So if I have -1 to 1, it's still always 1.0. Hold on. Why? Unless I didn't reload. Yeah, so I get 1.0 in this case. And, if I change the negative to -3, it's always 1.0. hold on. So if it's mapping as 0.1, that means it is assigning it directly as the parameter value, but then somehow the number I'm getting here is a fraction of the, it's like normalized. But the parameter, oh wait, hold on. It's because this is in, no, it's not. Hold on. How do I have this mapped? The input. Oh, it's because I have the input multiplied. The input is, right, sorry, the input parameter is also getting changed. Which is not what I want. That's why I'm getting confused. That's why I'm getting confused. So only for the parameters that I'm setting as outputs, go from -10 to 10. Okay, now it is 1. Yes, okay, so there's no remapping. I was just confused because the input was changing. The inputs are remapped, but not the outputs. So that's fine. So it is just 1 to 1. So this is now 1.0. Am I rewriting Live2D in Rust? Yes! So now we have what I expect. And now let's see how this behaves. So we have some numbers here, and they actually look kind of interesting. They're not as round as the ones before. So I actually think this kind of makes sense, because the correct way to implement the pendulum is to do like a cosine thing to determine the influence of gravity. But when you're moving on or you're dragging the pendulum on the top axis, like I need to like explain this for this to make any sense. When you move the top of the pendulum like this, you're essentially taking a trig function on the like an arc sine or something like that, or a cosine on the deflection, and that's how it affects the angle. So then, because the motion of the pendulum would be based on the angle relative to gravity, you then take it like another sine of that or whatever, and that's where you get round numbers. Whereas if I'm changing the angle, then I expect these to be like irrational numbers. So let's see if that makes sense. I think that kind of explains the behavior we saw. So this is angle based. This is going from angle 0 to 1, which means that essentially the input, this is modeled as a pendulum where the velocity is 0, the angle is actually -1 radian, and then we set it in motion. And so then we have to determine the next time step. Now, and because of the way this is depending on the FPS, I think this is a very dumb formula. Because I remember implementing this in a way that was insensitive to FPS, and Live2D is clearly sensitive to FPS. So, which is really sad. So you might be able to offer a mode where, you have like smarter physics and less smart physics. So we have angles -1, and then we are essentially reducing, right? This is going to be offset. So if I print the, if I consider this an offset, I'm just going to redo this as an offset because it makes more sense. We subtract the input, right? And we're just going to call this oval. And the change is, oh, the change doesn't matter, but the, yeah. So if we do this again, oh, right, the input is not in radians, so I can just say 1.0. Actually, no, we can just do it times math.pi. The value I'm setting is 1 divided by math.pi, yeah, so if we multiply by pi, we get the value we want. Yes, and now it goes to 0, right? So our first time step essentially is these. And so we need to see if this matches something interesting. So what the pendulum essentially is going to do is going to say, okay, to calculate the influence of gravity, it's going to take the sine of the angle, right? Because at 0, you want it to be 0. So you take the sine of the angle and you multiply it by gravity, which is 1. And that gives you the acceleration due to gravity. And we assume all the if you assume all the coordinates are normalized, like there's no like multiplying by g or something like that, then we're basically taking the sine of 1, which is the input angle, or minus 1 in this case. And then we are essentially adding that to minus 1, right? So this is the influence of gravity on the thing. And in this case, we want it to be positive in terms of what it's adding to the value. And so then we have the time step. I think there's a time step here we're missing, possibly a frame. It says 363. Just gonna do some math to see if I get any interesting, like, related values. Now, I might be able to just Google this number if it's something large. Like, if it's an interesting constant, it might be something that we can just find the reference for, actually. How much is that in degrees, actually? I'm just kind of curious. But it doesn't make sense because it's always in radians. How much is that in terms of pi? Okay, that's not a nice number. Yeah, it's like hex colors or something like that. Okay. Interesting. You get the Wikipedia article for radians. That is sus. Hey, hold on. Gradients 63661. Okay, that's a hint as to how this number came up. It's just okay. It's just there you go. It's just math pi times 2. Okay, so that gives us a hint as to how this happened. So we have minus 1. And then we have times it that is this is actually math pi divided by 2. No, sorry, 2 divided by math of pi. Or minus 2, I guess. And then this one here, is this going to be a nice number? Not exactly. But since it's supposed to be like an acceleration thing, it's going to be more interesting, right? So I expect like it should be like squaring or something like that, right? I feel like I've seen that 2.54 thing before. Oh, look! It's pi cubed times 8. Which means that to go from this step to this step, what happened is we multiplied by a factor, because this is all like incremental. It's a factor of 4 times pi squared. Now that's a hint there, right? And that makes sense because there's going to be like a velocity value involved here. Now to go from -1 to -2 times pi, we multiplied by 2 times pi. So you see what's going on there, right? Now, does this make sense in trig terms? Or is it just like linear like that? Well, let's do a bit of Googling. Pendulum formula. Simulation step. Now, I don't want all the. I want like a discrete time step simulation. So I'm gonna approximation. No. So the interesting thing is there's no 60 FPS anywhere, which brings us to the Live2D Physics does not care about the FPS. Now the FPS is at least declared here in the physics file, so we can modify our simulator to actually at least be able to adapt to, you know, whatever FPS happened. But Euler integrate pendulum. And that looks like just what we had, doesn't it? Or something. No, that's just the time step though. I'm not sure. Now, the interesting thing is that when it crosses over to the other side, we can't just keep multiplying by a number like this. So that already makes me wonder what's going on here. I would expect this to be based on subtracting, not on just multiplying like this. Because essentially what we have is you need to have an acceleration value, right? The acceleration value should be proportional to the sine of, so you have sine 1 is the acceleration, right? And that is acceleration towards the ground. Is it? Hold on. No, sorry, acceleration is always, yeah, hold on, let me think about it. At 90 degrees it would be 1, at 0, yeah, 90 degrees, yeah, so it's just sine. So this is the acceleration coefficient. And then you would need to multiply the velocity by this. Like add it to the velocity, right? And then you would, does this make sense? My sine 1 is, at half the angle, you would have the, yeah, it's basically the dot product between the angle of the pendulum and gravity, which is the sine, should be. And so, if we think in terms of time steps, this is our acceleration in theory, right? And so then we, this becomes our velocity. But we have some kind of factor going on here. So the minus 1 plus sine 1, obviously that's too much. Now the sine of 1 is in terms of like 0 to 1. There might be a pi factor in here, right? Or like divided by pi or something like that. Let's look at the delta. So we have the deltas, right? 363, and then 379. That's a bit strange. I'm not really expecting. We're looking for 363 as a velocity kind of deal, right? Angular velocity. But this could be 2 time steps, which we don't have. However, this is multiplying by, so you have minus 1 and then minus 2 divided by, and then minus 8 divided by cubed. So if this is multiplying by 2 times pi and 4 times pi, then this is just multiplying by 1. So it looks like we haven't missed a time step. Is there a reasonable way to get to 363 from sine of 1? Let me add precision just to see if we have more numbers. Now, of course, it could be that their simulation is just terrible. Right, let's grab some numbers here. Is this a number that pops up anywhere? I think it's possible their simulator is just literally not even physically correct. Because we saw those like decreasing numbers that were very clean earlier, and I don't think that makes sense for a pendulum simulation. No, yeah, I mean, I know I can do a curve fit, but like, the thing is, this is a discrete simulation. So I should be able to come up with a formula that matches the individual numbers without needing a curve fit. And I already have this 2 times pi, 4 times pi squared. Like, I have some formula that happened here. It kind of looks like they're just multiplying 2 times pi times the value. Like, what happens if I just iterate this? Hold on. So if we have this is 258, which is almost correct, but a little different. Now this one's really close. 636, 61977, 6244. Hold on, wait. Minus 1 times pi. And then it's cubed. So obviously the 5 here doesn't work anymore, right? Because, yeah. So if it's iterative, we would be multiplying, basically taking the value, multiplying it by so if we add it like that, like minus 1 plus minus 1 times 2 times pi minus 1, for example, then we get that, right? And then if we do the same thing with this one, say a equals minus 1, and then we say a plus a times this. We iterate it. What's a? What am I doing? So it's not that. A times 2 times pi divided by pi minus 1. So in this case, if it's but now there's the problem is that now there's a velocity involved, right? Let's start a little Python script. And try to write some logical pendulum formula and see if it makes sense. So we would say a equals minus 1 and v equals 0 for velocity. And so if you do iterate as velocity plus equals math.sine times a. Actually, from math import star. So if the velocity is increased by the sine of a times something, and we don't know what something is, and then the a has the velocity added to it. Something like that would make sense, right? So in this case, the sine of a, I'm gonna go the other way around. Yes, okay. And so let's say we do this minus 2 or something. Okay, that doesn't work. How would we get a number there that makes sense? So maybe instead of the sine, they are just using some kind of approximation. So maybe it's the velocity is minus what we are doing here is times 2 divided by pi minus 1. Okay. So that gives us the right first number, but not the right second number. Because this doesn't really seem to be moving the way a real pendulum moves. Assuming I don't have any damping, which I don't think I do. Okay, yeah. So we have the this is the kind of formula, right? So this theta and theta dot. Theta is what we have here as minus 1. And then this is the velocity. And so then this is the formula, right? So let's see if we can do this, remap this. So we would say this is A. A equals A plus dt times V. And then we say V equals V plus dt times 1 divided by I0 times plus the U is what? That's, U is an external torque, okay? So we don't have any external torque. Okay, so the important part here is like we have a sine of x1 here. And this would be A, and this would be V. And the parameters that we want to use okay, this is the center of mass story, but we don't really care about that. This is just estimating the, okay, so I0 is what? Moment of inertia, which is whatever, okay. So these are just constants, so we don't really care what they are. And L is the length essentially. So if you just set rod mass to 0, because I want to simplify this. Yeah, this is just rod length as you expect. And then you would have rod mass rod length squared, I0. So you can get rid of that. And you have rod length here. Did I do that right? No, this is left to right in Python, right? dt times 1 divided by itself. No, that doesn't make sense. Yeah, okay, it's just the 1 is irrelevant there, but we want to just divide it by the I0, which is that. So we are minus bulk mass, so we can get rid of bulk mass. And then we have one rod length we get rid of. And you can just move the -1 there, and this is G times the sign and then we have B is what? Oh, friction coefficient. Okay, so this is friction. So this is the formula we have. And now, do these numbers make any sense? If you just set everything to 1, yeah, so we're back at the 159 there, and now, is there a dt that makes this make sense? What is the sign of 1.0? I think Wolfram Alpha's probably gonna give you something. Okay, it's a transcendental number, so we can't be doing sine of 1 because the numbers we're getting are not, obviously they're not transcendental. Unless pi is? No, there's no nice formula for this in terms of pi, right? Okay, I'm gonna try, instead of 1 radian, I'm gonna try 90 degrees because that cancels out the sign and see what happens then. So instead of 1 divided by math pi, the value would be math.pi divided by 2. What happened there? That is weird. Oh, because I didn't set the value? No, yes I did. Okay, that is very broken. Yeah, that is very, very unhappy about that. Okay, how about like 30 degrees or one of those? What is that? Is it 30 or 60? Yeah, 30 degrees. So if you set the sign to 30 degrees, which is times 30 divided by 180, that gives us a nice number for the sine. I guess they go into -1 all of a sudden. Oh wait, sorry, because this is not in radians. This is in radians. The 1. And to divide by math.pi because the input is in degrees. So if I set the radians to math.pi divided by 2, that'll be 90. Okay, there we go. So now we have something that starts very slow, which is very interesting. So if we set last to wait, why are we getting 9 frames there? Hold on, something's weird. Okay, now it's this one. So instead of output 1 minus last, what we would want is, if we keep last as adjusted by input 2. So wait, hold on. Why is it minus 0.1? Minus 1? Oh? Hold on, I'm just making sure that that I'm not confusing myself here. If I set the gravity to 0, which is acceleration, then it shouldn't move. It does move. Why? Oh, that's interesting. So that gains an initial speed and then doesn't change. Okay, I'm gonna take a quick break, but this is interesting. And it is slowing down. Okay, hold on. Be right back. I'm back. Jumping to Python. Nah, this is all gonna be just float. Like I don't care about floating point precision, and cubism is actually C++ or whatever. Okay, so this is important because it means that you can see there, if there's no gravity, the pendulum is actually rotating, and it is gaining initial velocity, which I did not model. So that's one reason why my model is very broken. So that means when you rotate the pendulum, you are actually applying a force on the bob. You're not just rotating the frame of reference of gravity, which is what I thought was happening. There's something going on here. So it gains a velocity. Now our input here, let's go back to radiance because now the gravity is out of the picture. There's no sign anywhere. So there should be no real radiance value here. So if you just set radiance to 1, we somehow went from -1 yeah, this is interesting. Hold on. If I set it to 1, it goes to the right. If I set it to -1, it goes to the left. Okay. So if I don't do this adjustment here, the oval, because that's not going towards 0 anymore. See, now I have something. So there's a damping factor already somehow. And it's like subtracting 0.2, but there's something else. Okay, is this linear in the number of radians? I think it is. Not quite, actually. It's not quite linear. Is it repeatable, at least? I think it is, though. I think it is. The simulation is repeatable. Yeah, it is completely consistent. So these numbers are fully accurate, which means, you know, whatever time step or something is going on is a different story, but there is math here that is creating these numbers, and this is not linear. So is it -2? Okay, interesting. It looks like there is a friction component going on here, because let's try -0.1. Okay, look, that is very close, right? I think we're getting somewhere here. So try -0.01 and give us a bit more significant digits here. Yeah, so there's somehow a motion implied. This looks like another fudge factor and might explain some things. So essentially what happens is that when we move this pendulum, we are changing the frame of reference when we change the rotation. That is for sure. But then how does it affect the motion of the pendulum? Well, if we are rotating the pendulum, and we say negative radians, then we're actually gaining some momentum towards 0, just inherently from that. So let's get some numbers here. This is with radius 1, mobility 1, delay 1, acceleration 0, okay. And with the value, because we can start getting some numbers here. This is at -0.01, right? The momentum we are gaining is 1/5 of that. And some strangeness going on here. I hope this is not about the VTube Studio physics settings. Let me check that the VTube settings are actually round. Physics strength 50, wind strength 0, dragging physics strength. Okay, okay, hold on. There's one thing. VTube Studio lies with the physics strength. And I suspect 50 is not 50. That might explain some things. Because look, I noticed earlier, if I set the physics strength to... this is why I don't like VTube Studio. If I set the physics strength to 0, you will see that it actually does stuff anyway. See? It's doing physics. Why is this? Look, minus 01001. Isn't that sus? Isn't that real sus? Come on. So at physics strength 0, we have this. At physics strength 50, we have this. At physics strength 100, what do we have? That. Well, first of all, that's not even linear. Why is this curve? And about 25. I don't know if that's exactly 25. It lines up, I guess it is. Looks close enough. I see a power thing going on here. In fact, I know even if you turn off physics, it does the one thing. See? Like, turning off physics is actually physics 1. What is 2 then? Okay, it goes to 0, sorry. So 0 is not 0 then, sorry. Not 1, that makes more sense. Yeah, so it's times 4 for every doubling. Which means it's squared? No, it's 2 to the power of n, right? Or something like that. What's the span here? It's from 0 to 1 is 80 times. 80 times? That doesn't sound right. Oh, it's just squared, isn't it? It's just squared. Okay. So if you double the input, the output is times 4. So it's just squared. how did we end up with 5 times for the 0 to 20? I mean, I've done this before, you know, with spreadsheets of all things. But, I guess like divide by 10 times whatever. That kind of makes sense. Wait, what? Physics strength 10 is... the same as 1? A 0? Oh, so they're setting a minimum to the physics strength. That's... Why is everything horrible? Magic numbers. I mean, spreadsheets are convenient for like tweaking formula parameters and seeing how, like, you know, looking at the curves and stuff. I know how to use solvers and things like that when I really need them. But when the numbers are coming up round like that, I'd rather just look at them. So, okay, they are, this should just be, it should just be this, shouldn't it? Yeah, it's just, I mean... So what's the minimum? 15 should come out at 1.8, yes. And then 1.0 would be... Okay, there instead of a min on the... Yeah, instead of a min on the physics value, it's a min on the output. This is the formula, right? And then times whatever the base factor of this is, which I don't know what it is. If 50 is normal, then it would be times 4. If 50 is normal, then this is the formula. Which I guess if we put it in as a float, then this is actually times 4. Times 4. Okay, yeah. So this is the formula for the scaling we have, right? Which I guess means actually it's just 1 squared, and then 100 would be 2. So there you go. So it's the square of the physics strength, and then there's like a min going on there. So let's make a note here. Now, of course, that doesn't mean that this is squared intrinsically. It could just be that the formula that we are seeing has a strength that is squared. Thank you, syntax highlighting in Sublime. Yeah, you just get that, right? Oh, actually, I think that min makes sense because we're getting a very round min here. And if it were a min on the squared value, it would be some other... Like, the magic value would be something else. But because you're getting a magic value that is not like the mini, if this is 20, this is 1/20th, right? Is the minimum, which is 0.05. And that is not a there's not a round input, right? It's whatever that is, like. Yeah, that's not a magic number, which means this is actually this is part of the built-in min formula, because otherwise the output values like this min factor would be done before the squared, if the squared were part of how the calculation here happens, but it's not. So that said, that means that 50 is actually 50. And I think all this is doing is scaling the output of the physics engine. I don't think this actually does anything with the it doesn't affect the physics engine. But it's good to know. So that's not the source of this weird thing at the bottom now. So now what's going on with this again? Back to that story. So you're somehow adding a velocity that is a little bit more than the 0.01, but just a tiny bit more. So what is this factor, actually? If I just take this times that, okay. It's a very small number at the end that I don't understand. And yeah, this is well within rounding error. If this is irrelevant, then I don't care. But I think it's not irrelevant, because if you increase the... Oh, this has to be a sign of something, doesn't it? Because if you increase the radians to like -1, that's gonna be like a small angle sign of something. See, now it's much bigger, right? How was I writing these out? I think I forgot. Let's put these here. So this is at -0.01, we get this number. -0.1. So that means there's definitely a sign involved there somewhere, I think. We get this. So it's, see, the bottom is increasing much faster. -0.5. And -1. And if we do -2 even. Yeah, so there's some factor here. Like that's really big right now, right? And if we do -math.pi, something interesting is gonna happen, I bet. What about -4? See, now it's... Oh, it's the same. Okay, so... Oh, it clamps. It probably clamps to, like... something. Oh, no, it's because I have to clamp to -pi, is why. Because the input parameter goes from pi to... Yeah. How about -3? So we have some deltas here, right? This is approaching something. So if we write these differences out, and then we have a 6 here, so this is 239. And then minus pi would be whatever this is with, if minus 3 is, we were having 1/20th of the value. So if we have 0.5 divided by 20, we have, no, not 1/20th. What am I doing? 1/5. Yes, it's 1/5 of the value, so it would be this minus pi divided by 5. And we get this. Hold on, 3 divided, is this right? Oh, sorry, minus pi divided by 5. That's the offset, okay. So what's the difference there? How fast is it growing? Is it a square? Okay, it's not that. That's a weird fraction there. What about the these multiplied together? It's divided by this. 357. I really want to know what that extra thing at the end is there. Because it's like it gains additional speed. Like the initial speed is like 1/5 of the angle that moved. But then somehow has a little bit more. And then there's a drag function going on. Unless, hold on. You know what this could just be? This could just be a pi constant that isn't actually pi. This could just be a pi constant that's not actually pi. If I bet it's just a pi. They did their own pi. I bet. If I do this and do divide by 3.1415926 times math of pi. Okay, so now you have like. It's 4 zeros. Okay, so it's not quite 1/6, right? No, it's too much. Not quite, but something. I bet this is quite likely that it's like just a pi constant that's not supposed to be pi. What if there's a square involved? No. I wouldn't be surprised if it's something like that. Or it's like 2 times pi, right? What if I do, if I take this, I mean, no, it's not linear, so it can't be that, because there's a, it can't just be a straight pi, there has to be like a square there or something, right? Okay, hold on, let's try this. Divide it by the actual value we expect. And then, actually, let's get more digits, because we're truncating here. And I don't really want to do that anymore. So let's do minus 0.01. Okay, so we have this. Our cost minus 1? Probably, but... Because remember we got pretty round numbers at the beginning? I wonder if, you know, if oh, it's based on the same pi constant. Actually, maybe we can try those to figure out pi. If we use the, let's try that. If we do the x value thing, that might give us a more direct approximation of what was going on. Let's set this to x. And then, so we set the value to just value equals 1. So remember, that was giving us some nice numbers. And that's 0. Oh, yeah, right, because I probably with no acceleration, it doesn't like that. No, hold on. Probably needs more of this. No? What did I break? Oh, sorry, that's the output. I'm dumb. So the input to x. Okay, there you go. And now it's strangely not round anymore. Because we're converting to degrees. Let me turn on the acceleration again, because we were getting good numbers with that. Yeah, how do we get the nice numbers before? So because we already had a radians multiplier in there? Is this before I figured out it was radians? No. How was I getting the nice numbers before? I think I was positioned at 10. Oh, that's a shame. It's in the history somewhere. cool. I did reset the strength and all that. Oh, is this set to 10 and 10? I think it was set to 10 and 10. And it doesn't do anything? Oh, I'm not reloading. Hold on. Oh? Oh, right, because I need... No, I don't need to... I'm actually need the physics, so reload should be enough. What's going on? Alright, yes, position, so this should be, this one is 1. Did I have different settings here for that? I think I have to look at the history. When did I get the nice numbers? I can look at... I think I have some of them pasted here. Yeah, these, right? So I had like 0.25 was the input. And I was getting really nice outputs. I feel like I had these set to 10 at that point. No. Oh? Looking through my own stream log. Okay, there was one. He got scale 25 on the output, and... no, okay, that's just max. Yeah, I've sent the parameter to 0.25, and it was mouth X, and I think that was mapped 1-to-1 to the input. Yeah, it was 1-to-1 on mouth X. And I had the input as weight 10. And then scale is 25, I think. And I had all the vertex settings to 1, and normalization to position -1-to-1. Okay. Please work. Okay, that's it. That was the magic numbers. Okay. So with position, okay, this is with scale 25 on the output. So if I set it to scale 100, we're gonna get the bigger numbers. And it should still be clean. Yeah, -2, whatever, okay. And then I have weight 10 on the input. If I set weight 100 and I just make it smaller, it should still be fine. Now these are small angles, which is important. Because the small angle approximation of the sine and stuff applies. Where it's just equal to the input. Now the physics does, okay, this is, there's a scale of 100 on the output. Okay, so we don't need that. We can just go 1. And it should still be nice numbers, but smaller, which they are. Okay. And, so that's probably why this is so clean, because if there's a sine, the angle was so small that we have like a small angle approximation thing going on. And now it's actually staying there. There's no motion. Oh, mind you, there's one difference here. Python is calculating all of this in doubles. I bet Cubism uses floats. That could easily be the source of the problem. That's a little bit... Yeah. How do I fix that? Python float, 32 round. There's some gonna be, yeah, that's quite likely that's the issue actually. Because if I say okay, let me just add a function. Def of 32. Okay, so that makes sense. We have, most likely this is hitting a small angle on the sign, whatever there is a sign there. And I need import struct. Return. Yeah, so it's actually breaks at around that decimal digit there. Which is pretty close to where we are here, right? If I round this to F32. It's, yeah, it is a 32-bit floating point number, what we're seeing there. Oval. So they are doing the math in 32-bit float. There's probably a way to print that, actually. How do you do double? Python struct pack. Is there a Python print float in hex? Is there like a hex float? Oh, yeah, I'm doing this, but you can do dot hex, okay. I think. Yeah, you can see how this is rounded, right? To actually pretty. B? Oh, because this isn't okay. That's like very rounded. Hold on. That's not even rounded to just float 32. That's like rounded way more. Hold on, are they using like 16-bit floats or something? Or they have a rounding step involved? Because this is actually just a round float number. Like very round. That has like 12 bits of precision. Is it in F16? Are we getting that for everything out of the physics engine? No way. Like, that's not even nothing in C, 16-bit floats. What? Wow. They're all very rounded, more than 32 bits. It's not just 16 bits though, it's a bit more. Could it be fixed point? Because it seems to get worse as it gets smaller. Okay, they have some kind of... This is a clamp. They have something here that is like resetting it to 0 when it hits a certain number because they're like to stop the physics because there's no way this is dying that quickly. Because it's getting to much smaller numbers here. And I mean, that might make sense for a physics engine, where like if it goes to 0, you at some point just stop it. But this is really bothering me. How do you only get like 4 bits of precision at minus 18? There is no way. Because maybe I'm just chasing floating point error at this point. So the exponent is on minus 14 to 15. Which might explain these as denormals. I cannot believe they're using float 16 for physics. That doesn't make any sense. And this has more than that number of significant digits, so it can't be that. This is around 16 significant digits-ish. So is it because they are taking like a square root or something, and so because it is a 32-bit float, they lose precision? I cannot believe they're doing something smart with floating point numbers. And this is all code running on the CPU. Float 16 doesn't make any sense. This makes sense. Like a clamp when it gets too close to 0 and it gets clamped, that makes sense. But why is it losing precision so quickly? Fixed point? Because almost anything you do in floating point is gonna like add stuff to the digits. So it's almost like the last operation that's happening here is... Or is this like a rounding thing that you do on parameters? Is it possible that you're doing a thing on parameters where they round the outputs to fewer significant digits for whatever reason? Or they use fixed point for parameter values? But then, when converting to floats, in that case, the param settings I have on this one are on the output minus 10 to 10. But I mean, yeah, they can just multiply by that. But then whatever fixed point they're using is like in a power of 2, which, I mean, it makes sense, but... Okay, this is not actually parsable. Does this work? No. Yeah, so clearly more than 16 bits, 24-bit fixed point? 20-bit, 24-bit fixed point? Okay, hold on. So, one thing I can do is change the, range of the model and see if these do anything. So let's only print the first few. So this is with bounds of 10. And with bounds of 5. It's exactly the same. Which tells me that it's not based on like a normalization of the parameter value, which means they have to have room for more, for bigger values. So, do they have limits on parameter values? They might. They might not be documented. They probably don't have it documented, but I bet they do have like a minimum and a maximum that you can use. Well, you can just try making it really big and see if it like refuses the file. Ah, now it's different. 4789, 4783. That did something. Oh, now it's somehow different. Now it's not... Now it's certainly not repeatable. Okay. Now it's very not repeatable. And all I did was increase the range of the parameter. Because it was repeatable before, right? Four, 7, 8, 3. Yeah, it's repeatable with like 100. There's definitely something there. What if I give it a range that's like a multiple of 3? Doesn't really do anything. Or something weird like this. Is it like normalizing to the range of the parameter? No, it's still the same. It's still the same, so it's like it's truncating later? Well, this does mean that me worrying about those little float imperfections is kind of pointless because there is clearly rounding involved. In fact, I'm not even printing the full input value. Is the input value modified? Oh, look, the input value already has a funny thing, even just before physics. So that's real fun. I think that explains the extra thing I had. But this one's just float 32 though. This is just float 32 truncation, I think. Yeah, okay, now that one's just float 32. So the input parameter is at least keeping the right value, but the output it's like 24-bit floats or something. Like 8.24 fixed point? Mind you, one way this can happen is if they add a big value to the float and then subtract it. And then that will essentially break the precision, right? See, this kind of thing will do that rounding, right? Hold on. Is it just adding like the... Ah, okay. I might know. I might have an idea of what's happening. They might just be adding the, like, normalizing in terms of the output parameter. That makes sense. Because I have it set to 100 and 1, 2, 3 here. If I set it to 10 and 10... it's still 4783. Okay, so what happens if I set the output? We are going negative. So what if I just set it to, and that's 0? No, sorry. From 0 to 1, and we go positive. I need to recreate the Mach 3. I think I made more precision now. For 7, 8 to 8. Okay, so for 10 it still does that, but I think that's what's going on then, is that they're... And yeah, this is close to F32 precision though, so... Okay, so I can't worry about tiny little differences because of floating point error. So I guess just make tests with larger numbers then. Okay, so I think we have some kind of sign involved because that is and this is getting closer to the right precision, so okay, so for the small angle approximation, the output value we're seeing, the first one, is 0.02 for 0.025. Fine. That is because, remember, there was the thing with the... If we turn off the... If we turn off the acceleration... Okay, then it doesn't move. And you can see the position loss there. So when applying a movement, it doesn't gain momentum, or is it just because it's too small? Yeah, it doesn't gain momentum. Okay. So we know we're starting with this kind of number, and we don't have many digits of precision. And the value we get at the output is actually exactly the same as the input for this case, just negative. And then it starts getting a little bit smaller. So for -1, am I still in scaled by... It's -1 to 1 and everything is 100. So we're in natural units. And then we have 785 for -1. Now I expect a because the length is 1, I expect like a square root to happen. So it would be like the if you pull the pendulum off to the side, it's probably doing like an arc sine. One 1.41425356. Okay. I want to start plotting this somewhere. I wonder if this number is something Googleable. Don't have enough precision though, so let's write that. Oh, 45 degrees. Okay, that makes sense. That makes perfect sense. The pendulum is 1, so when it moves over by 1, you get 45 degrees to the original point. And I guess then it just sets the value to that. So the way you calculate that is, how does that work? Oh, arctangent. Right? I think. Hold on. Am I right? No, I'm just brain farting. Sorry, yeah, arctangent of 1. I'm dumb. The arctangent of 1. Okay, so the way the input is applied is the obvious way, I guess. It just takes the... Let's put some stuff in here. X motion. It just takes the... It's something like that, right? And it probably is not additive then. If I do, so this is minus 0.5, sorry, this is minus 1. Yeah, it's like approximating, right? You would get the you get the 8 of 0.5, and then you would get the A10 of like not 1 but minus that value, right? So the current x would be the sine of A10.5. That's the first value. And then you would calculate that. So it'd be A10 of we're adding 1. So it's 1. Hold on. So A equals A10.5. Not quite. Sorry, delta divided by xp. No. No, hold on, what am I doing? The x position is 0.447 at that angle. So we're looking for 366, and the delta is 0.552. I think it should be the angle from the... But the thing is that it doesn't reapply, right? Like if you do it the first time, you get 75 once and it stays there. Because the angle is already pointing at the... Right, so it's the angle between the current angle and the angle to the... Right, okay, yeah. It just moves it to that position, ignores the length. Now this is really weird because it should be taking... The pendulum can't get longer. But I guess it's maybe just keeping X and Y separate. Somehow? No, it must be just considering it close, right? So we have... Right, okay, it would just have the... Basically what it's doing is... Let me get some Inkscape. Need some diagrams. So the pendulum is here, right? And the length is 1. We're just going to say this is 1. And that's the control point. Now, the control point was right by 1, right? What it's doing is it's saying this, taking this angle. That's the 45 degrees, right? And so then the pendulum would actually be, the new position would be like here or something, right? At 1, length 1 from here. So if it moves again, this is the angle we need to calculate. Which means we take the angle as an offset from the current point. Let me just write this out. So what we would say is, okay, we calculate the angle of the previous x, right? So we know the dx and the dy from the previous x, because we know the length and the angle. Says this, the OX is the sine A and the sine A of the cosine A times the length. The length is just 1 in this case. And these are deltas from the current position, right? And so then the angle we're trying to calculate is that with the x added, the new position added to that. Let's say dx, and so the new angle we need to we want to have is the arctangent of and are we doing positive or negative here? Hold on, just make sure I get my numbers right. We're doing negative dragging, and then the angle is increasing. So I guess it's yeah, that makes sense. So I think the angle is, as it moves left, the angle increases. So if we do y as top is 0, yeah, if you do Live2D coordinates, the sine is the x and the cosine is the y. And then the this is the delta angle. And so then what we want is the basically that. .463 and 814. 463 and 814. Yes. Okay. That's exactly what I expected. And then rounding error. So we know the X motion. Okay, so that is important to know. And there's no momentum imparted by X motion. Now this is useful because there's no momentum imparted by X motion. That means that we can see how the pendulum behaves now. So if I want to have a nice round number in radians, what is like 30 degrees? It's like a square root of 2 or something like that involved. There's something. The tangent of 1 is this, which I forget what it is, but I think it's something. So if I give it that number as the value, we should get my 1 radian on the output. Force at new GXL plus winder angle, the arrow, delay day, delta Vs, new P rotate parent. Okay, this is wrong. What happened here? Oh yeah, I'm doing multiple. I'm doing something weird. I need to do this one. And that's not right. Is the input parameter clamped? It might be. I think it clamped from 0 to 1. Sure, I'm not doing any silly. So -1 does get me 785. -2. Ah, wait, hold on. Something's clamped there. Yeah, it's clamped to 1. Yeah, we need to make these bigger. Or I can change the physics to the map. Yeah, we have -1 to 1. You can use a 10 here. So if you remap it like that... Okay, yeah, we get 1. I'm gonna take a very quick break. I'll be right back. Okay, I'm back. So now we have a way to make the pendulum go to -1 without imparting any momentum, which means that we can enable gravity and see what it does there. So now we add gravity. And it's clamping because I changed the parameter, but I'm gonna undo that because I actually do want it to give me nice values. I'm giving up on like tiny float accuracy because they're clearly doing some horrible stuff. Aha, and see now, you can see that the first time step is already applying gravity, which is why it was difficult to make sense of this before. Now, the interesting thing is that in the first time step, it only went back by 0.2. But then in the next one, it accelerated a lot more. In a strange, non-linear way. Like, I would not expect that. Let's change the time step function and make it a little slower, see if it makes sense. Delay seems to be a time multiplier. Let's see if that maybe gives us like 10 times the resolution or something. So you can see it accelerating towards the center. Now I want to change the delta thing here so it actually shows me the minus IRAD thing here, and IRAD is input to times 9. Let's make this 1.0. No, that doesn't work because of that. No, that's not what I want to do. What I want to do is the previous thing. Change apple 1 minus last. I have to set last. Is minus 1.0. No, that did not work. Oh, sorry, it's 1.0, not minus 1.0. Okay, there we go. So now you can see the velocity. And so then if we make this delay 1, it goes way faster. Now this is strange. Why would, in the first time step, would it go accelerate just a little bit, and then in the next time step it would go much faster? That's kind of a hint as to how they are implementing this. Because it should be accelerating the most at the very beginning. The fact that it's not kind of means that there's some kind of time step thing going on there, maybe. What if it's a delay up to like 1/4? Yeah, so on the first time step you get a very small value, and then it somehow actually ends up in a constant speed? Almost? That's not how pendulums work. That is not how pendulums work. Okay, hold on. There's a legacy physics thing in VTube Studio. I wonder if the new physics is like based more on the... What happens if I do that? Actually pretty similar. The first one is almost identical, like within rounding error. Pretty much. And then after that, it's a little bit different. Oh, and actually now it's kind of not stopping, which is what I expected with the coefficient set like that. So somehow legacy physics oh, it's effectiveness, okay. Does not say. Great. Undocumented. Okay. Cubism might have something here. So the effectiveness is the value I know about. No, what did they call it? Effectiveness. And like gravity set to like -1 here and stuff. But is it this? Is it the weight? Ah, it's here, okay. That's just the input. Now they call it influence, and maybe that they renamed it. I guess that's. I guess it used to be effectiveness. But yeah, at least now it's still bouncing which is what I expected it to do. Not much there. I think it's the input thing. Well, I guess let's try to figure out legacy physics first, because it seems to be a little bit more predictable. Oh, actually, yeah, look, it's not rounding anymore. Now it's full precision. Oh my gosh. So it is a rounding thing they do. No, wait, no, that's still big now. Now I'm confused. So it doesn't change that much. 7027. Oh, okay, no, it's just not as predictable. Okay, so now it's not predictable. And I'm getting full floating point precision on the outputs. So it's not repeatable now. That's a shame. Is it because I set the delay to 0.25? Yeah, now it's repeatable with the delay set to 1. Okay, what if I just change gravity? What if I just change the gravity to 0.25? Yeah, okay, so now it's less crazy. Oh, look, okay, so now gravity. Hold on. No, that doesn't do anything. So this effective forces is what is changing? Okay, the x did something. So the gravity magnitude doesn't matter? Just the angle? Looks like it. Okay. So if I set acceleration to 0.5, that should be a gravity multiplier anyway. Oh, hold on, not there. Okay, yeah, that's slower then. Okay. So if I set acceleration to 0, we get no gravity and it should just stay there. Which it does, except for a tiny error. I'm making full precision now. Ah, that's slightly different with legacy physics off. Okay, so if I set acceleration to that number, which is a nice number in floats. Is it at least repeatable? 992.993. No. So it looks like if I make the gravity weaker, it somehow ends up introducing more error. So why would it not be, like, deterministic? At 0.5 it is. At 0.25 it is. At 0.125 it is. Wait, now it's deterministic. Okay, it's not quite deterministic, but it's really close. Okay, good enough for me. So it's almost like it's almost like it's breaking the time step down into smaller pieces and only applying the input parameter change like late. So you only get a partial influence. Now, if this is one actual time step, then we should be able to but the weird thing is that it's only very slowly accelerating. It's like it jumps. Not about legacy physics. Doesn't actually change that much. It's a minor change. Looks like legacy physics is less predictable. 70255. Yeah, maybe. And it's possible that it is actually using the time step of the FPS instead of just like literally just counting frames. I guess one way we could do that is like, I think it likes to... Is there a way we can lag it? Like... Or if I make it like big, doesn't really change it because the GPU is pretty good. How can I make this slower? Maybe resize the window will do something? Yeah, that'll probably lag it. Yeah, okay, it's definitely not running at window FPS. It is using the real time of the frames, which is why we would have some non-determinism. Now that complicates things. And that complicates things quite a bit. Okay. Because then it's not a single time step. However, what I don't understand is why I had so nice round numbers at one point. I guess it's small. Oh, it's probably just because of float precision. Because I had numbers that were so small that it was just like dividing by 2 or something. What about when I had those pi times 4 things going on? Those are not small numbers. If you go back to angle and leave this at 1 and set this to, again, this kind of thing. I'm looking for minus 6.28. No, that doesn't make sense. Why did I get 4 times pi squared? That doesn't make any sense. I lost what was going on here. Six, 3, 6. And 2, 5, 7. Okay, so it was this. It was 2 divided by math pi. Okay. And then, so that was with a -1 input, which is supposed to be that. Yeah, 2, 5, and 6, 3, 7. Okay. So now it's somehow when we're doing this angle input stuff, it does actually kind of make sense. But now we have the issue of that imparting initial velocity. And so I guess maybe subtract that and see what happens. Because the x thing is not aligned with the time step and I don't like that. So if I set acceleration to 0, there's no, let's go back to that. If it's set to 0, there's no, there's no, no gravity. I wonder if legacy physics behaves any different here. Let's try a, that's a value in radians of -1, and we're getting some strange numbers out. But this might be, it is slowing down, but, yeah, okay, this looks like it's 1 time step in, because if I do, sorry, how am I doing this? Times 2 minus that. Yeah, 991, yeah, so it's slowing down, but we're basically getting about 0.2 worth of motion. So 1/5. And does it scale? Yes, it does. It's linear. And if I go and turn on... We are legacy physics, okay. So, yeah, it means it's minus 1/5 is applied as force to the, I guess, as initial velocity to the pendulum. So basically, I should start writing a simulator of some sort here and try to make sense of this. We're actually gonna have to have a class here. Pendulum. So the first thing we do is apply the having last in A and last in X. So it's A in and X in. So this is the angle delta, and what that does is it applies it to our angle. So self.A is the opposite of that, dA in. But also self.V we gain a velocity like that. And then we say self.A plus equals self.V. So -1 radian. That did not work. Not working. Huh? I'm kind of hungry, but not too much. What?
I heard you say you're hungry.
No, I did not. Yeah.
I want to sleep.
You can take a nap.
Your phone?
Huh?
McDonald's.
Mm.
I sent you a message.
Sorry.
It's okay. Did you go to the bathroom?
Yeah.
Oh, this car.
It's weirder than I expected.
Nande?
I don't know.
What's weird?
The algorithm they're using.
Oh.
It's very strange. It's very broke.
You're reverse engineering that? Or are you writing your own?
I mean, I have to like write my own that works the same, right? Wait,
Arigato. Did you see the message?
no.
Can you get McDonald's? If I fall asleep,
Are you gonna order it or not?
I am.
Oh, you can pick it up? I don't know if I'm gonna hear it though. I might not hear it. I can try. So we have at -1 we have 791 590. But that's because there's drag, right? At 0.1, it's actually much closer. So let's do a 0.1. And that's not working. Why not?
Hi. Older.
Okay.
What do you want?
I just get this.
Hmm?
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 Mm-mm.
What do you want?
Okay.
Hi. Do I just click next?
Discord order.
Google Pay? Boom. This room is so cold. You good?
I'm good. Oh, we have some random stuff here to remove. Okay.
So cold. Moving.
8 and then it's 601. Oh, I forgot to set the last. Okay, 0.8, 0.6, 0.4, yeah. And so that should match this. 0.8, 0.6, 0.4, yep. Did
you order your drink?
Yeah, it's in there.
Okay, so you will have mizu.
Hey. What? So, one interesting thing is that the velocity is not decreasing here at all. Like, there's some kind of rounding error, but it's not actually going down. I don't think at all. So the damping thing they're doing is not really damping. Now, I did say to... Yeah, it's not changing. Or maybe a tiny bit, but... Yeah. But if I set it to 1.0... it does go down. I guess it is changing, but very, very slowly. So that must be like a friction coefficient thing going on. Where, like, maybe at this speed, the change is so small that it gets lost in float precision. Oh, also, now I'm getting numbers that are actually not rounded, interestingly enough. Oh, it's because I'm subtracting this, isn't it? Yeah, it's because I'm subtracting, okay. So in principle, that should be returning it plus AN because of the way this works. Okay, so... this is kind of interesting. How did I end up with a much different speed this time? The time step changed, I guess, on the initial thing, and then it like... Huh? Wow, okay, that's sad. But it's that non-deterministic. Okay, what if I said it is the threaded physics? Because then it might actually use a more reliable time step? Ooh, okay, fun. That means it skipped the whole frame there. Yeah, you can see it skipping and doubling frames on the output. But at least the number looks a little closer. So maybe that's better for testing. Oh, and actually you can see it kind of lag even, which is kind of a good thing for me. Yeah, I guess we're gonna use threaded physics, even though it does some weird things sometimes. It's probably more reliable than FPS if it's using the time step. So then it's doing some kind of damping thing. Yeah, it's CV squared is the force. So because it's V squared, it'll be much smaller when V is small. So let's just, at this point, I think I'm just gonna like kind of estimate and try to get it close, because given it's not really entirely repeatable, it's not, and the weird running issues, it's not really worth it. Now, I don't know how this is calculated. And I need to add the sign. How do I do that? Does Python have that? And I guess the angle does loop back at 0, so we can do a I normally angle like that. So if I do, how many steps I've at? On the I'm doing 50. If I do 50 simulations here, it's going to V equals 0.01. So not nearly as much drag. Wait, hold on. 0.02? It's 0.2. That's -1, sorry. We're looking from 0.2 to around 0.92. So much less than this. That's closest to that. But the angle is all over the place. $922, $930. Now remember, the FPS here has something to do with it, so 0.12. It's pretty close. And then because it says integrating, if we can get the... This is 0, minus 2, 1, 0, 1, 2, 6. Actually, it seems to be... Okay, yeah, it's because of all the rounding error they have. Let me copy my F32 thing here, so at least we can round to 32-bit floats. I guess I should have learned this in like Python or something. Sorry, in some other programming language. Actually, it's really close. Yeah, I don't know what they're doing with the floating point. It's really strange. Yeah, about 0.09, it sounds like it's the drag coefficient that kind of gives the same angle, even though the velocity is a little off. Another possibility is that this is using new V instead of V. No. No? Ohio. Sorry. I don't think this really does much of anything, but
Ridiculous.
yeah, it's not a precision thing.
무슨 일 타게 되네?
I eat it. I eat it. I eat it. I eat it. So this drag coefficient is kind of a magic number, but it's hard to say where it's coming from. So if I set it to 120 FPS, the result is completely different. Yeah, so if I set it to 120, it does run physics faster. Than intended. What happens if I set the FPS at 120 here? Still for a second, so it looks like this doesn't really do anything. It's not changing the speed though. So somehow changing the FPS is changing the number you get on the first click. Oh, because if the FPS is faster, then it considers the initial acceleration is different. Okay. So, right, so this 5 has to be related to the FPS. That's why. So if the FPS is faster, then somehow that is different. So if we're running at 60 FPS, we need 0.2. $300. That's an interestingly magic number. So if you're running a DT, so it's 300 times the DT. No, sorry. It's DT divided by 300. Sorry, times 300. DT times 300. Yeah, it's DT times 300 as a factor that we divide by. Now let's see if any of the input parameters affect this value. So this is mobility value. And that does... That's kind of interesting. Mobility 0 means it only changes the angle by the same amount, but it doesn't stick. So I guess mobility 0 is probably just setting the velocity to 0 after every iteration. Which means mobility 2 is probably gonna just make it explode. Yeah, that seems likely. Except it somehow stopped somewhere. There's like a maximum speed going on. And it's depending on the FPS. Okay, so it's a maximum speed per frame. Because normally the FPS does not affect the speed. But when it's maxed out like this, it does. I wonder what this number is then. Okay, so mobility is 0.1. Yeah, it's just getting multiplied by the speed on every iteration. Now, because we are multiplying the velocity we're adding that to the angle on every iteration, we need to put a time step here. So if we multiply this by dt, that means all of our values are off by a dt. Which means we don't need to multiply this dt here anymore. And so this maximum dt is in terms of the FPS. And that's a strange number. No particularly round numbers here. It's likely related to the drag then. If k drag is 0.09 and the angle is multiplying by the new velocity, then we need to like divide this, like invert this. It's maybe 50 or 100 or something like that. KV as mobility. So we set that to 2. How did it end up with this? That's wrong. Is it right? No, that's wrong. Hold on, let's try this one again. So I do need a DT here actually. DT squared, I guess. No, that's broken. Two 8156. What am I doing wrong? Okay, drag is gonna be an issue. Let's not do this for now. Okay, that makes sense. And then the drag coefficient is gonna be very different because of that. So you have a speed of 12. How do we correct that? Before we had 0.2. It's just 0.04. Now we have 12 squared. And that meantime smaller, which I kind of like. 2.5e minus 0.5, that makes sense. That's a reasonably reasonable number. And now what's the problem here? I need to put the reference somewhere, like the known good. It's basically this. Okay, let's just put this somewhere. No, key drag is too small. Ah, there we go. It's that. Okay. I don't know why I messed up, but that's... Okay, that's the drag coefficient. Which seems, you know, like a number that could be just hard-coded somewhere. Now this one I don't know if it's a constant or not, but let's set it like that. Is it possible this is... no. Okay, so if the mobility is 0.1, you should get something similar to that. Actually quite different. Oh wait, no, because I'm already I'm subtracting the thing there, right? I need to stop doing that. No, I'm not. Hold on. Hold on. The mobility is 1. Yeah, that's because I was yeah, so we're not adding it, and we're not doing that. Yeah, it's like that. Okay, so 208 and 231. Yep. So it's 222. Close enough. So it's possible this case step is a little different. Instead of 300, it might be well, first, if I set the mobility to 0, it will just apply it once. Yeah, 208, something like that. Okay. So I need to get the same number as that as the output. So it's a little bigger than that, actually. So 815. That number's a little sus because of the dt squared. 12.5 is a because if I move this dt square, this inside the dt, it's like 17 squared, right? As dt times k step. I don't know. I don't know if there's a nice number for this. But now the problem was that on that 120 FPS, it was only double, wasn't it? Wait, still 208 on 120. Huh, okay, hold on. Okay, that's weird. So if mobility is 1, then at 120 FPS, it has double the influence, double the speed. But if mobility is 0, Okay, that means that actually it's not applying it, the DT. It's just applying it twice. So it's like the input to the SDK. Should I look at the SDK API? This is getting a little ridiculous. That sounds like it is applying to the physics thread this delta twice. So what about 30? Is it just gonna happen like 1 out of every 2? No. Why is Vita Studio so jank? If I say matchup FPS, okay, what if I make it lag? It looks pretty constant. Okay, so there's not really a... I think that's just a bug at that point. It doesn't make sense for it to change depending on the FPS. I kind of want to look at the API now. Because that doesn't, like, are they taking derivatives as inputs or what's going on here? They might not even have information on physics here. And I want to look at the GitHub, because the GitHub is forbidden. Stabilization, interesting, okay. They have so many weird hacks. I'm gonna eat something. I guess this is so that it doesn't... I guess this is basically resetting the physics based on the input parameters. Okay, so they do have a delta time. Okay, so they just have they just they don't describe any like options for tweaking parameters here, so maybe it's just a bug. I wonder if it has something to do with the FPS declared here. No, it was ignoring that anyway. Okay, that has to be a bug then. Maybe we're gonna ignore that. Okay, you can see it running at 30 FPS. And you can see it's also doing the processing much slower. So if it runs at 30 FPS, everything runs slower. Hold on, but if I change the FPS while it's running, it doesn't actually change anything because it is using delta time. However, that means that it's actually wrong in the other direction. This speed should be double at 30 FPS. So the problem is it's not getting divided down at 120. So it is affected by FPS then. At 30 FPS, it's applying 1/2 the effect. It's applying the same. It's applying the effect. Yeah, it's applying it to the delta t. Okay, that makes sense. So at 30 FPS, it's applying. It's always applying 208. It's just that at 20 it runs twice as fast. And so that means that the time, the velocity is affected by the delta t. Is it? Hold on, no. The velocity does not affect the delta t, it is constant, and so that's why depending on the delta t, it runs twice as fast. So then it is just, but okay, hold on. But then, because the velocity is stored in terms of the... this is so confusing, okay. Okay, so then there's a square there that shouldn't be there or something like that. Yeah, there shouldn't be a square there. So it's doing this much per frame. Which means the actual delta t value at 60 FPS would be this. In the theory, we end up with half. So it's actually 12.5 divided by delta t. And I messed it up again. Let's turn off drag. Because mobility has to be 1.0. And that's not right. Okay, hold on. Yeah, so we want velocity to equal 12.4 or whatever, right? And so then, for an input of 1 at a delta t of 60, okay, yeah, 750 is a reasonable number. 750 divided by 160. Sorry, times 60th is 12.5. Is that right? At 130 we want it to be slower? No, it's wrong. Okay, so it is just 208. Hold on. Yeah, I guess it is just this. I have no idea where this comes from, but I guess it's just that. Nope, still off. Why am I so bad at this? We're looking for this number and divide it by delta t. What am I doing wrong? I'm so dumb. Oh, that's it. It's just okay. It's and it's just the 12.5, which is a reasonable number. Okay, and then at 130 delta t. No, that's not doing what I want. And I said it's because this is v. I want like a delta angle actually. No, that's wrong. Sorry. Ah. Okay, that's what I wanted. I'm so bad at the... Yeah, okay, so it's 200, and then if we add the... drag... Yeah, so 30 feet, so we have the 208 thing, and if I set mobility to 0... we still have the 208 thing, so 208 thing is supposed to be, without any mobility change. So if I copy this... And that's at 30 FPS, but I want to do this at 60. We want to end at like 1 to 6 or so at 60 FPS. So now we need to adjust the K drag because the initial speed was a little off. Want to end at 126. So a little less drag. Sorry, a little more drag. It's 208. Let's set this value like exactly just to see if it's relevant. And then the drag, the drag would be I'm not sure which one of these is the drag coefficient. How is it delay to 0 and mobility to 0? What happens then? You get 208.156. Oh right, yeah. So there is a I can use a smaller number to test the effect of the drag. If it's applied on the first thing. So if I do 0.1, yeah, then the effect is, wait, then it's closer? So something is speeding it up. Something is speeding it up. And then there's drag. Okay, that's weird. But the input is 2. Can I do that? Ooh, then it's 468. So there's some kind of non-linearity here again. Huh. I guess I'm gonna have to plot these or something. Probably start using a spreadsheet. Do I have LibreOffice here? No, I don't. I probably should get that. Do I have numbers? Oh, I do have numbers. Okay, never mind. That should work. You just make sure it doesn't show anything weird. I don't think it does, but... I think you can just do some values here and just plot it. Okay, this is... I've never used numbers before. I hope this is not too complicated. So, yeah, I don't want to know what this is, because now this is very strange that it's... So we are not keeping the velocity yet. So this is just the first time steps velocity. And, wait, hold on. But one thing that is weird is that... If I set this to 1... And I set physics to 120... No, it is 208. Okay, yes, so it is just applying one frame. And then it clears it. It's actually an exact value, which is strange, because if it were keeping the velocity in terms of the time step, I would expect it to, have some error, but I guess if the floats are powers of 2, then it's probably the same. So if I do match app FES. Yeah, that's really sus. Because if the FES is the... Oh, wait, it's a little different this time. Okay. That's interesting. So the end value is the same, but the... It's somewhat caught, like, a little bit before the frame there. Yeah, it's like it catches it a little earlier, so it's not actually clearing out the velocity on every calc. Oh, okay, what it must be doing is also using the delta time there, somehow. Because mobility is, it was being applied every frame, but that doesn't make sense. It should be applied also according to delta time. So if I set mobility to 0.5, what happened now? Oh, delay is... Okay, if delay is 0, it doesn't do anything. Okay, fine. So delay is also involved in that. Yeah, so if I set mobility to 0.5, you can see it doing, 310? Okay, 208, yes. And like 386, because it's decreasing by... Okay, now it's weird. 60 FPS. Yeah, 208, 101, 50. Okay, so it's having every 60 FPS frame. And at 120... is very confused. Okay, let's try 30. Yeah, now it's having every 2 frames. Ah, but no, it's not, because this is a delta from over 2 frames. So, but you get before at 60 you get... Yeah, this is why this is confusing. At 60, you get 208, 310, 360, 386. And at 30 FPS, yeah, it is actually half as slow. No, but it does end up at the same value though. So, it is doing it right. Oh, okay, no, it's, at 30 FPS, it's taking more time to reach. Confusing. Who designed this physics engine? It's so weird. Yeah, see, so it is actually running at a significantly different speed, but it approaches the same value. Yeah, some of it. We're still working on things. I'm starting to get the feeling that what this is actually doing is it's computing the physics at a fixed rate and then interpolating the output. That's why you end up at that's why the first value is the same. That means the speeds and stuff are stored in terms of like 60 FPS ticks or something like that. And then when you pass in a delta time, it's just computing like that number of frames or something like that. And then skipping. Oh, sorry, I messed up. I always do that. because the weird thing here is the very first output value is exactly the same for 30 and 60 FPS, except for like a tiny rounding error. Actually, no, it is exactly the same. But then after that, it changes slightly. And yet we've seen that when it's set into app FPS, the first value can change a little bit, but then it becomes the real value. If we turn the mobility to 0, you get this kind of thing. Actually, no, A4E1, A4E1. Oh, that could just be rounding error. That could just be rounding error because it's always just +1 LSB on the next one. At 120, you get the E2 directly. At 60... Oh, now it's doing that too at 60. Okay, never mind. I thought it wasn't doing that before. Oh yeah, it's doing it at 30 also. Okay, never mind. I guess just mobility 0 isn't quite 0 enough for it. Yeah, it's doing this every single time now. Oh, no, here's one. Oh, this time it did it all in the first one. Yeah, so sometimes the time step is slow enough that it does it. You know, at 120, of course it would, because it's the right choice. Yeah, okay, it's doing it consistently now. So, so essentially it's applying a delta to the new angle. So the weird thing is, okay, we have a fixed value that is applied, and then it goes to 0. Mobility is 0. Okay, so the velocity goes to 0. However, if I set the mobility to 1, sorry, to 0.5, and we're still here in no gravity, then yeah, it is just, it's slightly different. It's ever so slightly different in this case. And it's slightly, unpredictable. Which means there is a time step involved somewhere. But it is just applying it frame by frame somehow. Yeah. So it does run faster at 120. It does run fast at 120, but then somehow, with the mobility set to 1. See, it's different in a strange way. It like dampens way more at 30 FPS. Wait, how did I end up with, 363 now. Hold on, what? I'm confused. I just said the mobility to 0. Acceleration is 1. Sorry. It's not supposed to be like that. Yeah, so now it goes to 208. Mobility is 1. When I change the FPS, the speed of the thing doesn't change. But somehow the effect of the delta does change. Well, the only way I can model that is as I said, with by storing the delta time in terms of the time step, and then dividing the change in the input by that. I think that's the only reasonable way I can do that. Essentially, what it's doing is it's taking the derivative of the input parameter, and since it's discrete, it depends on the time step what the derivative is. So I think we're back to just doing it the way I said. But then the weird thing is that on this first time step, it says it gets it to 208. Yeah, okay, I guess it makes sense. Okay, so let's try the simulate thing again. Yeah, so this has to be divided by dt then. Okay, so with that in mind, let's do a simulation. Okay, so this is at 30 FPS. So hold on, now the problem is that this is somehow applying the, oh no, yes, because it's applying the mobility for every frame. So because it is running half as fast, you actually only get half the frames. So it's like 25 frames at 160, and you get this, which is actually kind of close. Yeah, it goes to 2.6. Yeah, okay. So let's do 60 FPS run and try to tune the damping factor. So you actually want this to reach about 0 in this case. Over how many frames? So it's a little less because you have 3 frames of nothing at the beginning. We do the print the frame number here. Yeah, so it's starting on frame 3 in this case. And we go to frame 50. So I guess if I start this at -3, just to make it a little more consistent. Then frame 0 is the first one that has some output. And we do 48 frames. So you want to do 48 frames at 60 FPS. And we're looking to end up at 0.03 actually. Okay. So we need a little more damping. .12. No more actually. And end up at positive or negative? Positive 0.03. Okay, so a little more here. There, 0.033. 0.034, close enough, considering this is integrated. And then if I do a 30 FPS run, so at 47, it's actually at 23, we'd have a 2.61. And we're off. 19, what? Oh, we're way off. Okay, let me compare these two again. So this is at 60. And this is at 30. So the first one is the same, and then we have the 19959, that is close enough. Then 192, then 93, okay, so we're going to the, 159 here. Yeah, that's synchronized so far. Oh, then it's weird. Oh, what happened there? Oh, that's strange. That's like a frame skip or something. Try again. Okay, now it's really weird. Okay, now it's close. Let's just see if it's close until it messes up. Actually, no, this is all right. 261, okay. This one's good. So it started one late. But then we have 2.61. Yeah. Almost exactly the same value, 22, and at 44 plus 1 something. Okay, yeah. So, okay, so now the issue is that the drag is not taking into account the delta time. Because the initial value is right, and then the we have the other things at the zero. So the drag needs to take into account the delta time, which we're not. $22.05, $22.02. So it's not enough, actually. Actually, this doesn't make sense because even though at 60 FPS, the first value is already weird. What's going on here? Like, I have it reaching the same value, but not in the same curve. Actually, I do it is the same curve, but the deltas are different though. It's close though. This could be an interpolation thing. So we have the velocity. Okay, so let me think about this. They are applying the velocities are being applied on the right time step. No, they're not. Why is this so complicated? The initial velocity is double, which means everything here, all the velocities here are actually no, this doesn't make any sense. The theory feels when it's running, it's half the speed. For everything. And the mobility is 1, so that means that everything that's getting applied every frame is not getting applied every frame. Now, I know I just want to plot data, but the thing is, it's not even consistent. Like, I can guesswork the numbers Where's my phone? Why is it making noise? Huh? Where'd my phone go? Ah, here. I've done the plotting data thing before, but that first of all that was a repeatable process, and I had a lot of data points, and like there's so much weird rounding going on here. I'm just trying to understand the behavior before we even get to like tuning the numbers. The 30 FPS run is running exactly at half the speed. But then somehow the velocities are kept when I switch frame rates. That means the drag effect is being halved. Or in other words, they are not taking into account the... They're not taking into account the time step when calculating drag. So that means that it's fixed like that. One second. Okay. Because like we know their API takes a time step and not FPS. Yeah, I know how you're supposed to do it correctly. I've done it the right way before. The problem is this is messed up. So the effectively they're applying drag on every frame. Hold on, so the velocity gets clear on the first frame. This is the same, so the velocity has to be scaled by that for the real velocity to be different. But now this is behaving as if it is not calculating, taking into account the time step at all. Now we know the velocity is doubled here. But then the square doesn't make any sense. If the v is doubled, no, back to the drawing board. These cannot be equal if these cannot be close to equal if the velocity is doubled. So how is it possible for them to keep a constant velocity when you switch frame rates and yet behave like this, where after the first frame, the other thing is applied? This is extremely cursed. Like, you can see how it's visually goes much faster. And yet, the drag is being applied exactly the same. And yet, is it really keeping the speed when I change FPS? Yeah, look at that. See, if I change it here, and then it jumps back much faster. So, hold on. Like, everything I'm seeing points to a fixed time step physics system. But then how is it possible that when you change the time step, the velocity doesn't change? And they take the time step as input. But this does not make any sense. Like, you can see here, these numbers are essentially identical. It is running half as fast in 30 FPS mode, which means there cannot be anything that is not linear on the speed that is different. And yet, the speed is doubled as the influence from the input change like this, depending on the mode. And yet, the speeds don't, the velocities don't change when I change FPS. Oh, now it went faster. Maybe when you switch speeds, they're adjusting something. Okay, we're gonna try something different here. Yeah, let's start off legacy physics because now I'm getting confused by that. Okay, now they're doing something on switching because I just messed up the speeds big time. Okay, well, that explains that, I think. Look, the speed is randomly changing. What the hell is that 0? When it crosses 0, oh, when it crosses 0, it likes to change? Oh yeah, when it crosses 0, it likes to change. What? Are you serious? Okay, I think this is just too broken, and we're just gonna give up on anything like kind of numerically accurate, and we're just gonna do something similar because this is completely insane. I have no idea what on earth they are doing or what on earth VTube Studio is doing, but this is so broken. Like, look at that. The velocity just changes when it hits the top. And randomly sometimes. No, when it hits 0. The velocity changes when it hits 0. Oh, because it rounds to 0. It clamps to 0 when it gets close to 0. Oh, I think I know what's going on. I think I know what's going on. It's not storing the velocity explicitly, it's storing the last two values and computing the derivative. It's storing the last two values and computing the derivative. And so when it clamps to 0, it screws up the derivative, see? It keeps the change. 37, 162, and then 0, and then it suddenly keeps that. And something similar happens at pi. It's running to 0. So this time it speeds up. This time it slows down. This one speeds up. Yeah, for lit integration is what I was starting to think. I've done that before. So then essentially they store the previous time step, use that to compute the velocity, and so then they have all this stuff that is actually just run time step by time step. But then they are not storing the velocity, they're calculating the velocity based on the last two values and the time step. Does that make sense? Ah, こんばんは。ありがとう。スパチャありがとう。So, okay. So they're using an implicit velocity. And you can see it fluctuate, like sometimes the velocity goes up because the time step is changing. Yeah, you can see, yeah, this one is a little larger, it's a little smaller, right? Like this one has a lot in there with a larger time step, and then somehow a smaller velocity. And then the next one had a bigger velocity, so I guess it like just lines up. There's some delay there. Yeah, the previous one was small, so then we had a smaller change and then a bigger one. So it's like saying the previous time step and the current time step to calculate what to do. And so then that's why the clamping and stuff messes it up. And so then that means that they are doing that to calculate the velocities, but the actual damping and stuff like that, and the time and the step change at the beginning and everything. So the step change would actually just be a change in position. Which it does, of course. That's what the parameter change does. It changes the position, so then a fraction of that becomes a velocity, but not all of it. Or actually all of it. No, yeah, I guess it would be a fraction of it because essentially you're applying a fraction of the change to the output directly, and then the other would come from the change in gravity. Which is kind of like a change in frame of reference. Can I fake my system clock? Yeah, I was thinking of that. I could do that on Linux. On macOS, it's kind of painful. I don't really know how to do it on macOS. Ah, you can change it per block, right? Yeah, that's useful. Okay, let me look up Verlet integration. I've done that before. I remember there's a thing, a nice page for this somewhere. You okay? どうする? What do you mean わかんない? I'm sorry, I can't do anything about him.
Me neither.
The neighbors are making noise and we don't know why.
And like I heard you and then you made all positive.
I know, it's not us.
I know it's not us, but it sounds like.
I know, it sounds like it's us, but it's not us.
It sounds like it's chopping
Mm.
on the chopping board.
To me, it sounds like someone hammering something.
But yeah, and it's like if it was chopping on the chopping board,
It would not be that loud.
then the amount of meat is constant.
No, yes. Okay. Anyway, but the problem is the time step can change. So how does that affect this? Like, does roulette integration work at the variable time step? Or maybe they just messed up and they just... It's entirely possible that they, like, just don't care. Because as long as the acceleration is low... Basically, we don't need to change the acceleration, but it's already going to be doing that. So, the problem is that it needs velocity to apply the acceleration. So I guess it computes that from the xt minus delta t. Set it first to do then recalculate with new frame rate. What do you mean? It sounds like the integration done wrong, basically. Yeah. How does Euler work for physics? Actually, Chibi always has the most obtuse things. I mean, they're definitely using the previous position to calculate the time step. So, like the velocity. Okay, yeah, I think we're just gonna throw away whatever they're doing, which is ridiculous, and just set it to 60 FPS, which is what everyone uses, and figure out roughly what their constants do at this frame rate, and make it behave roughly the same. and that's gonna be that, because this is ridiculous. Oh, wait, it must be implicit Euler, because we know there's some weird damping that's not supposed to be there. And implicit Euler has that built into it. That would make sense. Maybe. No, I doubt they're doing this because they need to solve a system of equations, and I doubt they're doing that. No, they're definitely not doing that. Okay, I'm just gonna grab values, put them into a spreadsheet, derive some formulas that roughly match, and call it a day. Let's see. Let's get some dumps in here. We have and we know the crossing 0 is messed up, so I can't even really rely on that. Which limits how much reasonable math we can do. So I think 50 frames is more than enough. We know crossing 1 is also weird. Anytime it gets close, it's weird. So anyway, this is a step function we have for this stuff. How does this paste into this? Not very well. There's no paste special. Okay, I have no idea how numbers works. I'm gonna use LibreOffice because I'm used to that. So this actually makes me real suspicious of a certain other Live2D reverse engineering project that I think has physics and claims like, you know, accurate results. If their physics return accurate results, that means they decompiled Live2D, because there's no way this is reasonably duplicatable based on the output only. I mean, you could do it, but I highly doubt anyone has. So yeah. Okay, let's make a spreadsheet. I can paste special or something. Shift Command V. Yes, thank you. Okay. So I don't care about these. These are the deltas. They can be computed. So you know the input is 1. Let's compute some derivatives. So if this is essentially subtracting like a drag from the output. No, I am not going to decompile anything because that is a violation of the end user license agreement. I don't think that flies legally. Like, you bought it, but you didn't technically agree to it. I think that Steam does prompt you with the EULA, but I'm not doing that. Read the FAQ in the project. I'm definitely not doing that. So so I probably want to have a division here instead of regular derivatives. And get the factors in here. And then get 1 minus that. So that's how much is being subtracted from the velocity. And so then if we take the velocity, which is this, and divide by how much is subtracted, Actually, the other way around. We take this divided by the velocity. And if we do it again, if this is a square, it should be like that. Kind of, but now we're getting into precision errors. Now, we do have some time step issues here. This is supposed to be 60 FPS though. Let's plot this graph and see what we have. I mean, I know I can use like solvers in Python, but I'm using this to visually identify like, you know, what is the likely like behavior of this. It's a little easier to mess around with a spreadsheet. I've done this before with a spreadsheet when I did curve fitting on the Apple Silicon GPU power usage curves, and that was a whole bunch of fun. And then I used the solver. Like once I had the formulas understood in a spreadsheet, then I used the solver in Python to actually just get the best values out. But this is more like exploratory, because if you just use a solver, like yeah, sure, you can fit some polynomial curve to it or something, but you don't really understand what it's doing, right? You don't even, it doesn't, it's not clear if you are just fitting a random curve or actually kind of doing the same thing the original is doing. That's why I'm trying to use this. Because for example, with the Apple thing, with the Excel, I noticed that it was a piecewise function at one point because they were, you know, splitting something. And that's much harder to do with solver, right? You end up with a curve that just like kind of follows the piecewise function average. I mean, sure, Jupyter beats it if you are like used to the APIs, but I'm not, and then I'm going to be looking up the APIs all the time just to draw some graphs. I've done it before. It makes sense for some things. I'm just not sure it makes sense for this. For me, anyway. So we have here, this is V. This is the essentially acceleration. That's the multiplier for the speed. So the like. I guess it's more like we want the actual acceleration. We want to take the. Hold on, let's move this over and put acceleration here. So if we take acceleration divided by the velocity, and then we do that again, still it's not quite right. Yeah, that doesn't quite work. this v-squared idea kind of fits. Let's try a bigger number, actually. Let's try -2 radians. What value do you use for time when you calculate ACC? That's, no, I mean, I'm assuming a fixed time step right now, which is not true, but it's, like, close enough, I think. Because we if it's running in a thread, hopefully it's at least somewhat consistent. And this time is coming from YouTube Studio, but I'm not sure how, you know, related to the thing it is. Now, this is a little annoying, the pi jump here, but it is... I think I can just fix that by hand. And get some more data. Let's try this again. Hold on. So now we don't need... Let's clear this out and do this again. So the only thing is we need to fix this jump here at 3.14. So let me can fix this as this minus this, and then just move this over. Make this minus actually because it's nicer that way. It goes positive, and then I can just say equals this. Does pi work? It's interesting that this is exactly pi. I'm not sure if that's actually this kind of legit. Huh. I wonder if that's a coincidence. That looks a little too... That looks a little too exact to be a coincidence, and the... Well, let's see what happens when I replace that. Now, the pi here is a discontinuity, which is really annoying. Yeah, you can see there's a discontinuity here. That's really annoying. But somehow the velocity doesn't jump too much in this case from the discontinuity. But it does jump a little bit. Wait, what happened with V here? Oh, we skipped a frame, didn't we? Ah. That was very wrong. You take off the second two things in here. Okay, that's close enough. Save this somewhere. Oh no, we still have a skip there. What happened there? Yeah, it's 1.99. Okay, I might have to use application FPS for this. Otherwise, it seems to always skip a frame somewhere. Maybe this time is okay. Let's see. Okay, yeah, that looks better. I think we didn't have any skips this time. So ZV should be calculated in terms of the previous V. So mind you have the square thing. Is it constant? No. Yeah, it's just velocity squared. You put v squared in here. So the difference between these two, 49 and 81. Yeah, it's not v squared. Could it be v cubed? No. Though these two numbers are suspiciously similar. How does this curve? Let's graph these things. So this is v cubed. And that's the division. Let's move this over. I get a second axis on this. Like that. So that is not very useful. Let's delete that. Okay, can't do that. And we can put T on the second axis. Almost looks kind of exponential. I'm just trying to approximate the function at this point, because they're doing some kind of drag thing, and I don't know what it is, and I just need a function that kind of tracks this. Okay, let's do the dB inverted. So that it's a little easier. Let's get rid of T because I don't think it's that useful. And move these to the second y-axis. So this one's the v cubed is really suspiciously similar to the minus delta v, but it's scaled a bit different here. Yeah, I'm thinking it's exponential, but so you think it's oh, it might just be that. It could just be that it's doing an alpha thing on the velocity. Yeah, that would kind of make sense instead of a drag. No, wait, that doesn't make sense because it is not No, that doesn't make sense with the time step. It cannot be just exponential. You know what it kind of could be? Could it be trick-based? Because for starters, the initial angle here was not linear, was it? At -1. Okay, if we go back here, turn off the mobility. It's 208,157 at -1. And at -2, it's 468,534. So it's not. It's okay. For starters, the initial impulse applied is not linear. So we have -0.2 at -0.1. So it's like 1/5 and then some extra weirdness. Yeah, then it goes to like 468. So for starters, the very first value has a non-linearity with the input angle. At -3, it's 839. Yeah, I think there's a sign or something going on here. Yeah, I think it's gonna be a trig. So this is something that speeds up with a greater value. I think that actually... Isn't that been connected to a K-spring by design? Is it? No, I don't think so. There's different angles and pies and things here. You think it's like a spring, like a horizontal spring instead of a pendulum? But I have no gravity right now. Let me do a little experiment. So that's interesting. So if we are incrementing the input by a fixed amount, the first one is 208. The second one is 215. It's actually larger. The next one is 220. Man, this is so cursed. This is so cursed. How is this possible? Like we have the motion essentially damped it to 0. So why is it like more sensitive to input changes after this? let me try printing the all that might divided by A, right? That doesn't make any sense. 대丈夫.
Am I too loud?
No, I can't hear you.
You can? How is it? 대丈夫.
That doesn't make any sense.
I'm sorry. I hug you. Why does it doesn't make sense?
I don't know, it's so cursed.
Why is it cursed?
Ask them.
Tell me. Tell me what cursed you.
No, it's terrible. Like, the numbers don't make any sense.
Oh no. It didn't put like an intentional function to make it.
No, it's just broken. Like, I found several bugs already. It's complete. Look.
Yeah?
Like, I can run it, can run this thing at like -1 without this. And look at this. Oh, sorry, turn the... Okay, 2 to 1. It's basically going in a circle now, right? So you can see left to right.
Oh.
Look closely. No, that's normal. But wait for it now. Look closely when it crosses 0.
Yeah.
And keep looking.
Looking?
Like when it crosses 0.
Yeah.
See, it just slowed down.
Why does it slow down?
Because they have a bug.
They have a bug? Is it a feature?
There's a bug. See, now it's sped up.
そうですね。なぜだよ? わかりませんです。
It's no, I know why that happens. That is a bug they have, but the whole thing is so cursed that like there's no point in trying to clone it exactly because they're so broken. But at least I'm trying to understand like how some of the scales work, and it doesn't. See, now it's sped up again.
すごいな. It's like they put a randomizer.
No, it's just broken.
Can I drink your
Yes, you can drink.
頑張ってね。何が欲しい?
大丈夫. I think I'm probably gonna stop reusing because this doesn't make any sense.
Really?
Yeah.
We can sleep together?
I think so. I'm kind of exhausted. Like I started thinking this made some sense, and then the more I look into it, the less sense it makes. Like, what is going on here? How does it make sense that you change the value and the input by the same amount, and the effect on the pendulum is different? It's stronger after that. Weaker, I would understand because of like, you know, the friction thing they have or whatever. But stronger? So even for small values, it's greater every time. It's like 1/5 except not 1/5. This doesn't make any sense. I mean, 0 has to keep decelerating because there's a rounding. There's a weird rounding thing they do when it reaches 0, and then they calculate the velocity based on the rounded value, so it messes everything up. Like, this is so buggy and so broken. Hold on. Not what I thought. Just trying to Google it in case there was anything there, but there's not. Okay, I just realized one thing. Because they are doing the rounding at pi, I can see how many digits of pi they have by not rounding and just printing the thing here. Because they come to pi, so if I set mobility to 1 and do like a lot of dumps. Here, okay. Okay, so this is how many digits of pi they have, and I think that might just be the normal thing in float 32. Yeah, it's the same value. Okay, so what they have in F32 was. Yeah, it's just F32 pi. So they do use all the digits of pi at least for that. In F32. Okay, let's see what the other values do. So, so the 208 thing seems to be insensitive to the time step pretty much. Yeah. And the physics state and everything. Well, how about the other things here? If delay is 0, still there, so it doesn't care about that. How about the radius? Doesn't care about that. Okay, if the radius is 0, it does care, but that seems... No, actually, that's a little bit interesting. Alright, the radius is 0, it just seems to always set it to... Yeah, it just sticks there, I guess. Yeah, so the radius doesn't matter for reasonable values. But if you make it too small... Yeah, if it's too small, you get 0. Okay, I think I know what they're doing. So remember how at least at one point, the rounding happens at pi and at 0. They're not rounding at pi and at 0. They are rounding the x-coordinate, which is 0 in both cases. Now, if the radius is too close to 0, then the x-coordinate is always rounded to 0, and it goes away. With that said, I need to start plotting the sine and the cosine of the angle because I get the feeling something is off. Like I think they're doing a physical XY simulation more than a pendulum, like velocity versus angle kind of deal. And actually, the documentation might have a hint about this. So they say angular street is tilt in the z-axis direction, but I wonder if that's really what it's doing. Sorry. Time. Okay, so nice and lined up. Like geometrically, there has to be something going on here. What if I make the input stronger just to see what happens? Now, if this is rotating, you would think that making this bigger than pi would wrap around. And it does. Okay, so it does wrap around. Is this a magic something? Nope. And if I do 120 FPS, nothing changes. Let's put another decimal in there just to be safe. Yeah, so we're still, this is just running to F32. Nothing on Google. Or in DuckDuckGo. Let me check Google real quick. Just to make sure there's nothing. Doesn't look like it though. Is it possible that it is a difference that is involved? So over... I found a table that has a value, but it doesn't. I think it's just a coincidence. Let's see. Or like a division, like over divided by IRAD. Alright, it doesn't work with 0. Nope. No, nothing. How is this calculating this? It's so weird. Okay, I think this doesn't make any sense because they are probably applying like a drag function and then applying a drag function and then stopping the motion. So it has to do with the drag. It's not just trigonometry, which is why this is okay at slower values. So we're back to this mess. What could these possibly be? What could this possibly be? if they're clamping x to 0, that means they are storing the coordinates as x and y. Which means that this is probably not being simulated as a pendulum, but rather as a physical system. So I probably should stop thinking about trigonometry. And we know they're using the previous position and the current position as units to calculate the velocity. J3 negative. Yeah. That's just because it's the first value. The velocity increases and then decreases. So I think there is something. Okay. They're probably not applying okay, let's do something different here. So we have this value, right? That is an angle. We can convert that to x and y. And in fact, that matches the position thing we have there. So now we have coordinates. Now we can calculate the velocity, not based on the angle in radians per second, but rather in x and y, which is probably going to give a slightly different value than a bit matters. Oh, I have a feeling I know what's going on. I think I know what this is. I bet what they did is they modeled the pendulum as just an object. This is probably using a very generic physics engine, actually. It's probably just an object that moves linearly and then is clamped every time step. And so that's where you get the weird trick stuff. I don't know where the initial value applied to the velocity, how that works. But I bet that this is partially why it is damping. It's not actually written to damp explicitly. It's just the fact that as the angles are projected back from a linear position, it essentially becomes damped. Essentially, it's a repeated application of sine. Of cosine, actually. What is the cosine of 468? $855. Multiplied by 468. 418. Okay, it's not quite, but I think this makes some sense. Because if you do like the cosine of, you know, you get something really close. So if you just apply this dx and dy is from the previous one, right? If we just apply those, x plus dx and same for y. And then we take the it was the arctangent of that. It's the same thing we did here, actually, in the notes. Oh my god, there it is, 855. That's what it is. I've solved it. That's it. Look at that. nothing. It's just a Cartesian simulation with very coarse time steps, which is a very poor approximation of a pendulum. Ah! This is ridiculous.
Nani.
I solved it.
How did you?
Just had an idea.
What's the idea?
It's not a. Basically, it's using Cartesian coordinates instead of polar coordinates for the pendulum.
So cool. You got that? Yeah. We can keep going.
Well, I kind of want to write something now that I'm not gonna do the rest of it, but I want to at least look at what the other values do. Now that this makes sense. Because this with no gravity, but of course gravity is just gonna be adding. This makes sense. They're just gonna be using this dumb Cartesian simulation for everything. Yeah, it's obfuscation through stupefaction is a good way of describing this. I cannot believe this is what they did. And I literally had the code written out for like hours because I used it for a different thing, and it was the same code.
Wow.
Oh my god. Okay. Okay. So I'm gonna write it. I'm gonna make the simulator work now. Delete all this. This is all broken. Delete. I need some vector math. Do I want to use? Gosh, I could just write this in Rust at this point. But I want to use Python for now just to make it a little easier. NumPy has vectors, right? I think so. I think they have this. Yeah, they have like dot product of two arrays, and then they do like angle of vector or whatever. Yeah, that takes a complex argument. Do I want to use complex numbers? I could use complex numbers, but painful. Number or sequence of complex numbers. I think arc10 is what I want. No. Yeah, single column array, I guess, but they have NumPy and linalg. Okay. This probably has useful stuff. Okay, let's use NumPy for now. NumPy as NP. So we have momentum, acceleration, and radius, and I guess XY. We can fix the XY stuff later, but and really radius is the radius of the previous point. it's not upside down. So then we would say step self. And we want a essentially when we rotate the input, we are okay, I don't know yet what the input rotation does because there's a factor there that I don't know about. I still don't know what the step function is in the beginning, but I do know how it decays. So we have the last position and the current position. And on step, what we do is we take the last position and the current position, that's our velocity. And we just continue that. Now, I don't know about the time step. If we are actually doing time steps. I guess I would have to adjust it by the previous time step. I don't know if it's doing that properly, but we could try. So then we clamp this to the pendulum. So the way we do that is actually we just normalize the vector at that point. This is not what I want, is it? Oh, okay, that's what it... Yeah, sure. And then I did the arctan too. I think you just do that, and then it would be the x1 over x2. So this might be backwards, but we'll figure that out. Okay, the angle is wrong on that. This point needs to be +0 +1. Yeah, there you go, 0. And so then, if we change the, if we just apply that, that dx and dy, and I did subtract origin in here for these calculations. Pause. So those are origin, but for your end pause is end pause. Basically normalized to end pause minus origin plus origin. Okay, so there's the 468 going on. And it's supposed to be negative, so I guess, there we go. First and second, 855, 1936, 1497, 1776. Perfect. 2035, 2278. See, once you know the magic formula, it's not curve fitting. It's just knowing the magic formula that actually works. And then there's no magic numbers anywhere. Now the only issue is this stupid clamping going on here, right? But I bet that now that I have the code written out like this, I can actually make sense of this. Because I think the threshold is 0.001, I bet. So now the x-coordinate is getting fixed like that, and I bet that even fixes the weird pi issue. Yeah, 339,889. You know, this is going in the wrong direction now. Oh yeah, this angle is wrong. What happened with this angle? Oh, no, it is right. This is 340.1993, and then 294.3295. Yes, exactly. Except this is 96. So almost really close, but I mean that's probably within the rounding error pretty much. 752, 433, 441. Yeah, there's a little difference there, but very small. So I probably need to normalize this first, or after, sorry. Nine four three two nine six 9430. Okay, now it's wrong in the other direction. Three two nine five 330, and we have 32996. So 3295 is closer. And this is probably just related to floating point precision, I'm guessing. Yeah, I think it's probably just the floating point issue. Oh, I can actually fix that in NumPy. If I do array and then give it a D type of float 32. Well, whatever. Yeah, it's really close enough for anything, really. So I think we're good. I don't need to worry about that little tiny thing there. So you can even replicate the terrible thing they do here. The misbehavior. So, now is... I would like to know how this initial number happens. From a radius. A rotation in principle. And I bet there's some kind of geometric thing going on here. Let's try drawing this out. So if we are rotating by 1 radian, actually let's do the 45 degrees because it makes more sense. Yeah, that radians math pi divided by 2. So we got 0.346603990, which is how many degrees? $19.85 degrees. Okay. So we have 940 and 339 as the sine and cosine. Let's put this here at 0. And we can make it a little bigger and like just kind of do the math. Let's make this 100 pixels big. And so we are moving it to 940 in the Y direction. This is 1/10, 941. Probably around here. And then the Y, sorry, the X. Which side doesn't really matter. You have 3466. So the input angle in principle was supposed to be 90 degrees? Yeah. So you're supposed to end up here. And we ended up here. Now, what sense does that make? It has to have some sense. Now we know that for small numbers, we are ending up at 1/5. Of the angle. And as we get larger, we actually end up at more than 1/5. Yeah, it's almost exactly 1/5 for small numbers. And the radius doesn't matter except for the rounding. So... I'm thinking if the value is being set to like 5 times longer line, but that wouldn't actually change anything there. Could this be a complex numbers thing? No, that doesn't make sense. Divided by pi integer divided. No. That's that. It cannot be integer dividing by pi. It's almost like it's rotating the frame of reference, but somehow it is like overshooting. Is it possible that it is just like a linear interpolation between this point and this point? Like it rotates everything and then it takes a certain percentage of that. Let's draw out the circle here. Oh, this is not centered. No, it's centered. Why is this one not on the circle? Hold on. It is aligned. It could just be Inkscape accuracy though, because I think Inkscape kind of estimates the circles somehow, so. That doesn't quite look right though. More accuracy. No, this might just be Inkscape precision though. That's wrong though, like something here, like this is like the Y is wrong. Anyway, close enough for this test. So, I feel like 1/5 of this would be less. What did we say? Let's find out. Object, scale, transform, make this 20% the size. No, that's not it. Doesn't make sense. Okay, so second です。かなり時間もやっても疲れないんですが、疲れてるんですけど、疲れちゃうんだけど、やるしかないって感じ。And then remember, when adding more, it was actually somehow making a bigger change. Which makes me think there's some really strange, like they messed up the rotation formula or something like that. That doesn't make much sense. Perpendicular to the arc, it could be that. Actually, that would make sense, wouldn't it? Let me get a little bit more than... Yeah, actually, isn't that just what it is? I think that's what it is. That makes sense, doesn't it? But it's not 1/5 of this, though. Like, perpendicular to the arc, it would make sense. Wait, but it's in radians. So if I just do a line of length n, like 1. And then there's a length of 0.25. Right, of course. 0.2. No, but it doesn't work. No, hold on. There's a conversion here, isn't there? The arc length is just in radians. Oh, and this is 90 degrees. Sorry, so not 0.2. This is I'm doing 90 degrees, so that's math.pi divided by 5. 0.628. Sorry, divided by 10. 0.314, of course. It's gonna be that, isn't it? Or maybe not, but this kind of makes sense. Or it's 1/5 the angle you get after adding this? So it's 157. If I do 157, does that this arc length? Looks about right. But we're somehow getting more, not less, so... And maybe this is some broken trick they did here. Maybe it just doesn't make sense and it's just broken trig. Because it gets worse as the input gets larger, which doesn't make any sense. Like, what if it's just the sign, the inverse sign or something like that? I'm looking for 3466. Yes, it gets larger. So the angle is 0.314. And at math.pi and exactly 180, what do we have? 903. Yeah, I mean, of course, this is 0.8. 0.8. I'm looking for something that explains this curve. Okay, I probably should just graph this. Let's take some samples, I guess. Let's get some samples in here and see if any of this makes sense. You mentioned to me once that reverse engineering USB protocols would be very similar to network protocols, and I've since invented a USB drive for a fancy USB microphone. Thanks. Hey! I'm glad to hear that! Seven. 0.8. 0.9. 1.0. 1.2. 1.4. Just gonna make a scatter plot out of this and see if it seems to follow a curve or something. No, I messed something up there. I'm trying to solve one last mystery.
Do you want to sleep first?
How about you give me 15 more minutes?
Okay. What's this?
That's an interesting curve. Well, looks like at least a second order polynomial is really close. Although I'm not sure why we did do that. Yes, I'm trying to make a replica of the Live2D Physics engine. I mean, with that R squared, it's kind of hard to argue that it wouldn't work, but that plus 0, 0, 1 doesn't make sense though. I need a 0, 0 in here. Can I force the offset to be 0? Not as good at solve. But pretty close, so, you know. I might just go with this. No, it's actually not that good. So I don't think it's this. It sounds like it should be some kind of trig thing. I mean, a degree 3 polynomial nails it. The problem is that we don't know how to then reapply this, like, the second time around, right? Like, there's some weirdness with the offsets. It's not just added. What happens if I do the opposite? What happens if I start at 1.0? And then go to 0. Ah, interesting. So we have our 902, and then we only go to 389. Is that like a squared thing? Not quite that. So if I do a small number like this, yeah, it does go to 0, right? And because of the rounding, yeah, of course. Even 1.0 is going back. 2.0 is when it starts getting weird. Essentially, it overshoots by 0.68 on the way up. And then on the way down, it undershoots by... Wait, hold on. That is 1/5 again. That's the 1/5 thing again. Oh, that's an interesting thing. So the 1/5 on the way up is 0.4. And then on the way down, it ends up at 1/5 of that, which is 0.08. That could be a hint. Or it could be coincidence. What is this number? I didn't check this intersection actually. And so at 37.10. There has to be a weird trig interpretation of this. Okay, hold on. Which direction is this going in? Because I might be missing some logic. If acceleration is 1, then I don't do the clear here. So it becomes towards the offset. So it starts out at right, mobility 0. Yeah, so it's going in the right direction. Okay, 0.468. Yes, if I add gravity, there is an... Why is it skipping frames now? Right, because I'm hitting the... Right, I don't need that. Yeah, so now it's like 747 and then it goes towards 2 and stabilizes. But this is interesting. Hold on. So with mobility 0, it's 468. With mobility 1, it's 468 and then it continues. With mobility 1 is 746964 with acceleration. Seven four seven 1346. Without mobility. Ah, okay, yes, it is kind of added to the previous thing. Okay. And these don't do any, and don't make any difference. Yeah, they don't. If I change the gravity angle, it changes, but I think it's mostly the same thing. It's 4-1 something, 468? No, actually it's a little different here. Okay, that's the same thing, just backwards. 468. I don't know what this angle is, though. If I give it some acceleration and mobility, what happens? Yeah, then it starts to 314, which is what I expect. But if I don't give any of these, it ends up in a weird place. Interesting. So if gravity goes backwards, it kind of just jumps between 0 and that. It's not very happy about that. Is this anything known? No idea. Okay, I think I'm gonna call that a day. It's possible that this is just an artifact of me using 0 values for everything, and maybe it'll make more sense if we actually turn on gravity and things like that. Yeah. I think I should be getting some sleep. At least we solved the pendulum iteration mystery, so that's that. And yeah, we need to figure out how this like whatever this is, how this works. Okay. I think I got a day. Thank you everyone for coming. As I mentioned at the beginning of the stream, Cyan and I are re-debuting as Tokyo Hacker Girls on August 1st. So look forward to that. Subscribe to the Tokyo Hacker Girls channel if you can. It's CH, if you go to chgirls.yt, it'll take you there. Let me... And, yeah, I'll see you all next time! Bye bye. Bye bye. See you next